The third confirmed interstellar object slipped into our telescopes almost quietly, just another faint light in the catalogue of the sky. It carried a name, 3I Atlas, formal enough to sound routine, as if another piece of rock wandering into view was nothing extraordinary. But that name disguises a truth far less ordinary. This is not a native of our solar system. It is not bound to the sun's comforting gravity. It is something older, stranger, faster, and entirely alien in origin. From the moment its path was plotted and its hyperbolic orbit confirmed, one question refused to leave the minds of astronomers and speculative thinkers alike. What if this is not the end of a story, but the beginning of something much larger? What if Atlas is the opening act, the first visible piece of a pattern we have not yet learned to recognise? The official explanation is clear enough. This is a natural comet, one of countless icy bodies flung from distant stellar nurseries and left to wander the interstellar dark. It carries unusual chemistry, yes, and a speed far beyond what we're used to seeing, but still within the boundaries of what celestial mechanics allows. For science, the intrigue lies in what it tells us about other planetary systems, other stars, and the materials forged in alien environments. But for the speculative imagination, the intrigue lies elsewhere. If this is the third, after Oumuamua in 2017 and Borisov in 2019, how many more might be out there unseen? Is this a trickle, or the first hint of a flood? When Oumuamua passed, the scientific community quickly shifted from fascination to reassurance. Its odd cigar-like shape and strange acceleration without a visible coma created waves of speculation, but official voices calmed the waters with natural explanations. When Borisov arrived, its clear cometary activity made it easier to fit into known categories, reassuring everyone that interstellar visitors were curious, but not alarming. Now with Atlas, the narrative repeats, but each repetition adds weight. 3 arrivals in less than a decade when none was seen before. The question grows heavier with each object. Is our technology only now becoming sharp enough to notice them? Or is something changing in the deep galactic background that brings them our way? The odds of timing cannot be ignored. Human instruments capable of sweeping the sky with precision are relatively new. Just a few decades of serious coverage in a cosmos billions of years old. To argue that we coincidentally noticed 3 interstellar wanderers so quickly after one another seems plausible. But coincidence begins to lose strength when each object carries something distinctive. Oumuamua with its unexplained acceleration, Borisov with its cometary clarity, Atlas with its unusual chemistry and extreme velocity, a trilogy of anomalies, not catastrophic, not threatening, but peculiar enough that dismissing them as mere random rocks risks overlooking something larger. This is where the phrase, "when a visitor isn't just a visitor," begins to matter. A lone interstellar body can be explained as chance. A second strengthens the idea of random cosmic travellers. A third starts to whisper of patterns, of signals hidden in the noise of orbital mechanics. The idea is not that Atlas itself is hostile or artificial, but that it may be part of a larger sequence, a slow unfolding of contact in forms we do not yet understand. The universe is vast, and if intelligence has found ways to disguise its presence, comets and asteroids may be the perfect camouflage. They arrive without suspicion, they pass with no resistance, and they carry within them material that could be engineered to look convincingly natural, while still serving another purpose. The official position of NASA and other agencies remains cautious. No threat, no artificial signals, no deviations from predictable orbital mechanics. Everything fits comfortably within the language of natural science. But beneath those official words, speculation thrives. Even cautious astronomers acknowledge that our detection rate suggests a galaxy far more crowded with such objects than we once thought. Billions, perhaps trillions of icy fragments flung from stars long extinguished, all wandering in silence until one crosses the path of our sun. If there are so many, then each one is an opportunity not just for science, but for questions that touch the boundaries of paranoia. What if these are not only the relics of natural formation, but part of something structured, coordinated, or intentional? The opening tension lies right here, between comfort and unease. On one hand, the mathematics of hyperbolic orbits and chemical spectroscopy provide reassurance that Atlas is simply a comet. On the other hand, history reminds us that new categories of discovery often begin with anomalies mistaken for ordinary. Pulsars were once thought to be signals from extraterrestrial intelligence. Quasars were once inexplicable until new physics revealed their true nature. Fast radio bursts baffled scientists before explanations emerged. Each time, the universe has proven stranger than we assumed. To say that Atlas is only a comet may be as premature as saying those early pulsar signals were meaningless noise. The speculative imagination pushes further. If Oumuamua, Borisov and Atlas are the first three, then perhaps they are advanced scouts, the quiet beginning of a wave of visitors. Perhaps the galaxy is filled with them, moving on schedules we cannot yet perceive, each one harmless in itself but together forming a message. The question is whether humanity will recognize the message before it is complete. This is not an argument for panic. Atlas poses no physical danger. Its closest approach is comfortably distant, its path predictable, its body too small to matter even if it strayed closer. The unease arises not from what it will do, but from what it might represent. If this is only the beginning, what comes after? Does the sequence end at 3, or will we see a 4th, a 5th, a dozen more in the decades to come? And if the numbers grow, will the explanations of random chance remain enough to quiet the questions? The first part of the story is always the easiest. A single visitor explained as chance. The second begins to stretch coincidence. The third makes us wonder if coincidence has worn thin. Atlas is that third step, and it may not be the last. What happens when the next interstellar object appears, carrying not unusual chemistry but something more startling? What if it does not just pass through, but lingers, captured by gravity in ways that calculations cannot easily explain? What if its composition reveals isotopes that suggest engineering, not geology? These are questions that Atlas cannot answer, but its very existence forces us to ask them. The narration that begins here is not about catastrophe, it is about perspective. The perspective that each interstellar visitor widens our understanding of the galaxy, but also deepens the shadows of speculation. Atlas is not just a comet, it is a mirror, reflecting our anxieties about what it means to live in a universe we barely understand. And if it is just the beginning, then perhaps what lies ahead is not danger, but revelation. A revelation that may comfort or unsettle, depending on what we are prepared to see. When the faint trace of light first appeared on July 1st, 2025, it looks no different from thousands of other detections logged nightly by telescopes scanning the skies. A minor point of data, flagged by software, waiting for human verification. It was only when follow-up observations confirmed its hyperbolic orbit that the true significance became clear. This wasn't a fragment of our solar system, nor a comet bound to return in predictable cycles. This was something entering from outside, crossing the boundary of our local celestial neighbourhood and carrying with it the deep silence of the interstellar gulf. It received a designation, 3i Atlas, and with that designation a story began, one that forces us to question not only what we saw, but what it means to encounter an object that does not belong to our sun. The object's brightness revealed little at first. At magnitudes faint enough to require professional instruments, it presented only as a smudge, a streak against background stars when exposures stretched long enough. In that streak lay velocity, and in velocity lay revelation. Calculations showed speeds exceeding 130,000 miles per hour, far faster than anything native to the solar system. Hyperbolic eccentricity confirmed it would not be captured, it would not loop back, it would not join the endless dance of asteroids and comets that orbit our sun. It came from the dark between stars and it would return to that dark when its brief passage was complete, To astronomers, this was exciting but not alarming. Objects like this were expected. Planetary systems form with chaotic violence, ejecting billions of icy bodies into the void. Over cosmic time, those bodies drift, cross paths with stars, and occasionally pass close enough to be noticed. From this perspective, Atlas was part of a broader narrative of discovery, a chance to sample alien chemistry and test models of planetary formation. To the speculative imagination, however, the context was different. Two had come before: Oumuamua in 2017, Borisov in 2019, now Atlas in 2025. Not a steady stream, but a series. For those inclined to patterns, 3 points make a line, and a line suggests direction. The dark becomes the stage for tension. What does it mean to encounter visitors from elsewhere? For most of human history, the skies offered only permanence. Stars did not move except slowly over centuries. Planets followed their patterns. Comets returned in cycles that, while feared, eventually became predictable. The idea that something could enter from beyond, alien not only in distance but in origin, was not part of the human story. Only in recent decades has the technology existed to notice such things, to recognise a visitor not as a local wanderer, but as a true foreigner from another star. That recognition is our first contact, not with life, but with the unknown itself. To call it contact may sound exaggerated. Atlas has not spoken, it has not signalled, it has not behaved in any way inconsistent with a natural comet. Yet there is meaning in simple presence. An object formed around another star, perhaps billions of years ago, now drifts through our solar system. That presence is enough to remind us that we're not isolated, not alone in our little corner, but part of a galaxy where matter moves, collides, and sometimes carries secrets from unimaginable distances. Each such visitor is contact with history far older than our own, and with possibilities we have not yet mapped. The first days after detection brought a surge of global attention. Observatories from Chile to Hawaii to Spain aligned their instruments to confirm positions and refine the orbit. Within hours, networks of astronomers coordinated through the Minor Planet Center, sharing data, plotting trajectories and issuing circulars. The orbit was pinned down with precision. Perihelion late October, closest Earth approach in December, safe distance, no impact risk. The facts emerged quickly, stripping away the usual fear that comets sometimes inspire. Yet beyond the safety calculations, a subtler question lingered. What exactly had come to us this time, and why now? Oumuamua had unsettled the community by refusing to fit categories neatly. Its shape, its brightness variations, and its unexplained acceleration sparked debate that continues today. Borisov, by contrast, was comfortably cometary, complete with tail and outgassing, reassuring in its ordinariness. Atlas arrived as a hybrid of sorts. Its chemistry stood out, unusually high carbon dioxide levels relative to water, unlike any comet seen before. Spectroscopy from the James Webb Space Telescope revealed numbers that seemed almost artificial in their extremity, an 8:1 ratio of CO2 to H2O, defying expectations about volatile behaviour at such distances from the Sun. It was natural enough to fit scientific categories, yet strange enough to trouble them. The dark context matters here. For centuries, comets were omens, their sudden appearance tied to fear, change and disruption. Science eventually stripped away those superstitions, revealing icy leftovers from solar system formation, predictable and harmless. But interstellar comets bring back some of that older unease, because they are not from here. Their chemistry, their trajectories, their histories belong elsewhere, in environments we cannot visit. In that sense, Atlas returns us to a kind of cosmic discomfort. It is a messenger from the unknown, and like all messengers, its message depends not only on what it is, but on what we choose to imagine it means. If this is first contact with the unknown, what are we learning? At minimum, that the galaxy is far more dynamic than we once thought. If 3 such objects have passed through in less than a decade, then the background population must be immense. Statistical models suggest billions of such bodies wander between stars, each carrying unique chemical fingerprints from the environments where they formed. From a scientific standpoint, this is invaluable. Each visitor provides data about conditions far beyond our reach, but contact also forces recognition of scale. Billions of wanderers moving silently through interstellar dark, only occasionally brushing against our awareness, remind us of how thin our observational net truly is. This perspective feeds speculation. If billions of objects wander, then why do we notice only 3? The answer lies in detection limits, telescope coverage, and chance alignments. But speculation asks another question. What if the ones we notice are the ones meant to be noticed? What if selection is not random, but guided? A civilization advanced enough to travel between stars might prefer to remain hidden. What better disguise than objects that appear natural, expected, and harmless? The thought unsettles because it reframes first contact not as communication, but as surveillance. To be clear, there is no evidence Atlas is artificial. Radio telescopes searched for transmissions, finding none. Its orbit follows gravity with predictable precision. Its brightness variations match cometary rotation. All evidence points toward a natural object. Yet the very absence of anomalies does not eliminate speculation. Some argue it deepens it. If an intelligence wanted to remain unseen, it would build probes that looked exactly like comets, down to the chemical signatures, down to the unpredictable tails of outgassing dust. The perfect disguise would leave no trace. In this frame, the fact that Atlas looks natural is exactly what makes speculation thrive. For now, the evidence is limited to what telescopes can gather: light curves, spectra, positional data. No spacecraft will intercept it. Its speed and trajectory make such missions impossible with current technology. This distance preserves its mystery. We are left with only light, and light is always open to interpretation. Within those interpretations, first contact with the unknown takes form not as discovery of aliens, but as discovery of uncertainty. Atlas embodies uncertainty, a traveller whose origin, age and purpose remain beyond our ability to pin down. The narrative of contact deepens when placed in sequence. 3 objects, 3 moments of realization, each forcing us to widen our frame. Oumuamua first cracked open the possibility. Borisov normalized it, proving such objects were not unique. Atlas now pushes the boundary further, with chemistry that refuses to fit and speed that defies comfort. The progression is not linear, but it feels like escalation. Each visitor raises the stakes. Each one forces us to ask harder questions. What will the 4th bring? What about the 10th? How long before one arrives that refuses to fit even the loosest categories? In the dark, the human mind fills gaps with patterns. That is what makes Atlas more than a comet. It is not simply a piece of alien ice passing by. It is a test of our readiness to interpret what the universe delivers. Are we prepared to treat these encounters as routine, or will each one reopen the same questions about intelligence, surveillance, and purpose? Contact with the unknown is not about aliens landing on Earth. It is about the slow accumulation of anomalies that push us toward conclusions we're not yet ready to accept. The first contact we're experiencing now is subtle. No signals, no direct communication, only the realization that objects from other stars can and do pass through our neighbourhood. That realization itself is a form of contact, because it forces us to see ourselves differently. We are not isolated. Our solar system is porous. Material drifts in, drifts out, carrying with it stories we cannot fully read. Each object is like a message in a bottle, but the language is unfamiliar, the ink smeared, the meaning hidden. We may never translate those messages, but their arrival is enough to change us. When telescopes return their data and press releases assure the public that no threat exists, the comfort is real. There is no risk of collision, no danger of catastrophic impact. The story ends neatly in official accounts, yet beneath that reassurance the darker questions persist. If this is only the beginning, what are we beginning? A new era of astronomical discovery? A slow awakening to the true traffic of the galaxy? Or something more deliberate? Something that forces us to reconsider what kind of company we may one day find in the dark? Atlas in the Dark is not just an object, it is a moment when science and speculation overlap, when certainty and paranoia share the same sky. It is the continuation of a story that began with Oumuamua and Borisov, but it may not be the conclusion. If the past decade has brought us 3 such encounters, the future promises more. Each will carry its own mysteries, each will deepen the questions, and each will remind us that first contact with the unknown rarely arrives in the form we expect. When Oumuamua appeared in 2017, most astronomers treated it as a statistical inevitability. With billions of stars in the Milky Way and uncountable debris flung from forming planetary systems, it was only a matter of time before one of those interstellar fragments wandered close enough to be seen. It was a curiosity, perhaps a once-in-a-lifetime sighting, but not something that signalled a change in how we view the cosmos. Yet just 2 years later, Borisov entered, another object with unmistakable interstellar credentials, complete with a glowing tail and activity that confirmed it as a true comet from beyond. Suddenly, once in a lifetime had turned into once in 2 years, and the statistical inevitability began to look more like a sequence. 6 years later, Atlas followed, stranger still, faster, and chemically more unusual. 3 visitors in less than a decade, each one distinctive, each one demanding explanation. At first glance, the pattern is simple. Our telescopes are getting better. Surveys like Pan-STARRS, the Catalina Sky Survey, and Atlas itself sweep the skies with relentless efficiency. Wide field detectors, automated algorithms, and rapid communication networks make discoveries inevitable that past generations would have missed. From that perspective, there is nothing mysterious about 3 interstellar objects appearing in quick succession. It is the same logic that turned exoplanets from rare oddities in the 1990s into a catalogue of thousands today. Instruments sharpen, coverage expands, and the universe fills with what was always there. In that light, 3 is not a pattern, it is the barest beginning of a flood. But human minds resist leaving it there. Patterns are irresistible, and when numbers repeat in sequences, speculation rushes in. 3 arrivals, each separated by a few years, carry the weight of rhythm. 1, then 2, then 3. It begins to resemble a countdown, a slow drumbeat from the cosmic dark. Each arrival distinctive enough to stand apart but connected by their shared status as outsiders. This is where scientific caution collides with speculative imagination. Is it coincidence that 3 appeared in such a short span of human observation? Or is it the beginning of a sequence we're only now noticing? The mathematics can soothe. The number of interstellar bodies drifting through the Milky Way is vast. Estimates suggest quadrillions of objects on paths that wander endlessly through the void. If even a fraction of them pass within the reach of our instruments each decade, then 3 detections make sense. Improved surveys guarantee more will be found. By this logic, 3 is not a countdown, it is the opening sample of a much larger population, and nothing about it should provoke paranoia. Yet this very reasoning creates its own unease. If the galaxy is filled with such wanderers, then their presence is not extraordinary but ordinary, which means the extraordinary lies not in their existence, but in the fact that we have only just begun to notice. The timing, the sequence, the sudden cluster of discoveries. All of it fuels the sense that something has shifted, either in our awareness or in the traffic of the galaxy itself. The first visitor, Oumuamua, remains the most unsettling. Its elongated shape, rapid tumbling, and unexplained acceleration continue to resist complete explanation. Natural models exist, involving hydrogen, outgassing or fracturing ice, but none are universally accepted. It lingers as a possible anomaly, a first note in a melody we cannot yet name. Borisov reassured, fitting cleanly into expectations of what an interstellar comet should look like. Its dust and gas behaved in familiar ways, easing the discomfort that Oumuamua had stirred. Then Atlas arrived, too fast, too old, too chemically unusual, and the discomfort returned, amplified by the fact that this was now the third. The sequence begins to take on shape. Odd, ordinary, odd again. The rhythm is not uniform, but it is enough to hint that randomness may not be the whole story. From a speculative standpoint, 3 is a dangerous number. 1 is anomaly, 2 is coincidence, 3 suggests intent. Human cognition leaps to patterns at the slightest provocation, and in cosmic matters those leaps can be profound. What if these objects are not simply random wanderers, but part of something structured? What if 3 is not just the beginning of a larger statistical sample, but the first deliberate signal of presence? Even if entirely natural, the sequence itself forces us to think differently. If visitors arrive regularly, then interstellar space is not empty, and we are part of a traffic network we do not control. That recognition alone transforms our understanding of the solar system. Countdown language inevitably follows. It is not that anyone imagines a clock ticking down to catastrophe, but the psychological weight of sequential arrivals carries that flavour. If there is a 4th, what will it bring? If a 5th, will it deviate further from expectations? Each arrival becomes a test, not of planetary defence, but of interpretive frameworks. How long before natural explanations feel stretched? How many anomalies can be filed under coincidence before the categories themselves begin to fray? The idea of a countdown is not literal. It is narrative. The sense that we are watching a sequence unfold, one that might lead somewhere we cannot yet see. Science pushes back against that framing. Orbital mechanics cares nothing for countdowns. These objects move on paths determined by ancient gravitational encounters, not schedules. Their arrival times relative to our observations are random intersections of trajectories measured in millions of years. To imagine design is to project human intention onto impersonal physics. Yet science itself has been caught off guard before. Pulsars, quasars, and fast radio bursts all began as anomalies that resisted explanation. Each time, speculation preceded discovery, and each time the explanation lay in natural processes stranger than anyone first imagined. The possibility remains that the pattern of 3 is simply the leading edge of a phenomenon we have not yet fully modelled, a cosmic process that makes interstellar wanderers more common in our vicinity now than in the past. The real discomfort lies in what the pattern implies about the future. If we have already seen 3, then we will see more. Each new visitor will test our frameworks. Each will carry chemistry, speed, and behaviour that either fits or breaks expectations. The pattern of 3 establishes a baseline. From here, every addition to the sequence builds pressure, either toward confirmation that these are routine, or toward escalation into the inexplicable. The line between coincidence and countdown lies not in what has already come, but in what comes next. This is where speculation shades into paranoia. Imagine, for the sake of thought, that these objects are not random, but deliberate. Imagine that an intelligence has seeded the galaxy with disguised probes, each one appearing natural, each one following trajectories that mask their true purpose. 3 arrivals in a short span could then be interpreted as the first phase of something larger, an unfolding reconnaissance, a survey of solar systems that have reached technological maturity. The countdown in that frame is not to impact or disaster, but to recognition. Recognition that we are being watched, catalogued, evaluated. The pattern becomes communication, not through signals but through presence. Even without intelligence, the pattern carries weight. If the galaxy routinely delivers such objects, then our solar system is not sealed. Material crosses boundaries, carrying with it not only chemistry but potential biology. The panspermia hypothesis, controversial but persistent, imagines that life may spread through such wanderers. 3 interstellar objects in quick succession revive those questions. If life can travel between stars, then each visitor becomes not only a messenger but a vector. The countdown shifts from metaphor to biology, a measure of how often the building blocks of life might cross from one system to another. Astronomers, cautious by training, prefer simpler explanations, improved technology, wider surveys, statistical inevitability. Yet even among them, the unease is real. The 3 objects we have seen so far are not identical. Each carries quirks, each resists easy categorization. The more varied the sample, the harder it is to dismiss the pattern as simple chance. Variety itself becomes the signal, suggesting that the galaxy contains not just many wanderers, but many kinds, each shaped by different histories, each carrying different possibilities. That diversity is what transforms coincidence into something that feels like narrative. The pattern also reshapes human self-perception. For centuries, comets inspired fear because they were unpredictable, outside normal cycles. The modern age domesticated them with orbital charts and mathematical certainty. Interstellar objects undo that domestication. They are reminders that the universe still holds surprises, that not all motion is predictable, not all phenomena fall neatly into categories. The sequence of 3 is a lesson in humility, forcing us to accept that our solar system is open, vulnerable to visitors from beyond, and that we may be at the very beginning of learning what that openness truly means. If coincidence is the explanation, then the pattern will dissolve as numbers increase. A dozen interstellar objects detected in the next 2 decades will turn 3 into background noise, one statistical cluster among many. If countdown is the explanation, then the pattern will sharpen, each arrival adding to a sense of inevitability, each one carrying anomalies that push us toward recognition of something larger. At present, we cannot know which frame is true. We can only wait, observe, and acknowledge that 3 is enough to ask the question. The dark between stars is vast, and most of what drifts there will never cross our path. Yet when it does, when something formed under alien skies enters our system, we cannot help but search for meaning. The pattern of 3 may be nothing more than chance intersecting with technology, or it may be the first whisper of a sequence designed to be noticed. Coincidence or countdown, the question lingers, unresolved, waiting for the next visitor to tilt the balance. When the orbital elements of 3I Atlas were first calculated, astronomers confirmed what the raw speed already suggested. Its path was hyperbolic, an open-ended curve that does not close around the Sun. Unlike the ellipses that bind comets, asteroids and planets in repeating cycles, a hyperbolic orbit is a highway that leads in and out without return. Such trajectories mark an object as a true outsider, a body not native to our system, one that entered from the galactic background and will soon vanish back into it. These orbits are the unmistakable fingerprints of interstellar visitors, the celestial evidence that the solar system is not an isolated island, but a crossroads where highways from the wider galaxy occasionally pass. For astronomers, hyperbolic orbits are both reassurance and puzzle. They are reassurance because they guarantee safety. An object moving that fast on that trajectory cannot be captured by the Sun's gravity. It will not loop back unpredictably. Its closest approach can be calculated with precision, and its departure is certain. The object comes, it passes, it leaves. That predictability makes impact scenarios impossible. Yet hyperbolic orbits are also puzzles, because they imply histories we cannot trace. Every interstellar visitor carries within its trajectory a record of countless gravitational encounters, ancient star passes, and ejection events that occurred in distant planetary systems long before ours existed. To follow such a path backward is impossible. The highways are too long, too twisted by the galaxy's turbulence. We can only know that the journey was vast and that the arrival here is the briefest moment in a story billions of years old. Why then do these objects keep finding us? The answer lies in both scale and motion. The Milky Way contains hundreds of billions of stars. Each star likely hosted protoplanetary disks where gravity flung material outward during formation. Giant planets in those systems acted as slingshots, ejecting icy bodies and rocky fragments into the void. Over billions of years, those fragments filled the galactic medium, drifting like dust between stars. The numbers involved are staggering. Estimates suggest that for every star in the galaxy, there may be hundreds of billions of ejected planetesimals. Collectively, this adds up to quadrillions of objects wandering in darkness, each one following hyperbolic paths determined by long-ago encounters. Against such numbers, the appearance of 3 within a human decade is not surprising. It is an inevitability. The highways are crowded, and we are finally learning to see the traffic. Yet inevitability does not lessen the fascination. The very geometry of hyperbolic motion carries implications that unsettle. These orbits are not gentle curves looping around a centre, but bold arcs cutting through space with finality. Each interstellar object moves too fast for capture, too unbound to belong. That quality sets them apart from every familiar celestial body we know. The planets will return, the comets will cycle, the asteroids will remain in belts and clusters. Interstellar objects will not. They are transients, strangers passing through, and their hyperbolic paths emphasize that alien quality. They are defined by departure even as they arrive. The highways themselves reveal the gravitational architecture of the galaxy. When an object leaves its home system, it does so with a particular excess velocity, a speed beyond what its star's gravity can restrain. That velocity carries it into the galaxy's general rotation, where encounters with other stars and clouds alter its path. Over eons, the orbit becomes randomized, tilted, twisted, accelerated. By the time such an object reaches us, its original home is unrecoverable. We cannot point to a specific star and say, it came from there. At best, we can estimate broad origins, such as the galactic thick disk for Atlas, suggesting it may have been wandering since the galaxy was young. In this sense, every hyperbolic visitor is a message from nowhere and everywhere at once. The fascination deepens when considering how detection has accelerated. For most of human history, interstellar objects surely pass through unnoticed. Without wide-field surveys and automated detection algorithms, their faint light would never have been separated from the stars behind them. It is only in the last 2 decades that our instruments have become sensitive enough to notice. This is why 3 objects have appeared in quick succession. The highways have always existed, the travellers have always been moving along them, but only now do we stand at the roadside watching. The impression that they keep finding us is not about their frequency, but about our vision. We are no longer blind to the traffic of the galaxy. Still, the framing matters. If these objects are always out there, then each detection is a reminder that our solar system is not closed. Cosmic highways run through it, and along those highways come materials we have never touched. Each one is a sample of alien geology delivered freely, carrying within it volatiles, ices and dust from stars we may never visit. From a scientific standpoint, this is extraordinary. A spacecraft could never reach these distant birthplaces, but the birthplaces send fragments to us. Hyperbolic highways are not just routes of escape, they are routes of delivery. The speculation arises when delivery is interpreted not as random but as purposeful. If civilizations exist in the galaxy, they too know about these highways. They too know that ejected bodies drift endlessly, crossing systems and carrying materials. The possibility that someone might use these highways deliberately cannot be dismissed outright. A disguised probe launched into interstellar space would naturally adopt a hyperbolic trajectory, indistinguishable from ejected debris. In this frame, hyperbolic orbits become not only signatures of randomness but potential camouflage. The very quality that reassures astronomers, its natural appearance, becomes the very quality that makes it the perfect hiding place for intelligence. Such speculation is easy to dismiss in the absence of evidence. No signals, no deviations, no behaviour inconsistent with natural mechanics have been observed. Yet the thought lingers because hyperbolic orbits themselves are strange. They are the exception in a universe dominated by ellipses and circles. To encounter objects that refuse to belong, that arrive only to leave forever, stirs unease. They feel like interruptions, and interruptions demand interpretation. Even if natural, the steady discovery of more such objects will force humanity to see the galaxy differently. Not as a distant background, but as an environment with constant motion, where highways pass through our own neighbourhood and strangers routinely travel them. The idea of highways also reframes risk. Though hyperbolic orbits prevent capture, they also imply that countless objects cross the solar system at high speed. Most will remain far from planets, but the sheer numbers suggest that some may pass dangerously close. The statistical likelihood of a direct impact is vanishingly small, but the potential energy carried by such fast-moving bodies would be catastrophic. In this sense, hyperbolic highways are reminders not only of connection, but of vulnerability. The galaxy does not isolate us. It delivers both opportunity and potential threat. The concept extends further when considering the galaxy's structure. Stars themselves move along orbits around the galactic centre. Clouds, clusters and streams weave together into patterns of migration. Within this grand motion, interstellar objects are like sparks thrown from the fire, drifting independently, yet shaped by the same forces. Their hyperbolic paths intersect with ours not because of design, but because of scale. With so much motion, so many bodies, so many eons, encounters are inevitable. The highways crisscross everywhere, and we are simply one intersection among many. Yet inevitability does not diminish meaning. To live at a time when humanity can detect and study these travellers is extraordinary. For all of history, the solar system seemed self-contained. Now we know it is porous, open to visitors from beyond. Hyperbolic highways are not abstract lines on a graph. They are reminders that we share space with the rest of the galaxy in ways we are only beginning to grasp. And if Atlas is only one of many, then the question is not whether more will come, but how many, how often, and how strange they might be. When telescopes track these orbits, they do so with mathematical precision. The numbers leave no room for ambiguity. Yet behind the mathematics lies the deeper narrative of contact with the unknown. Each hyperbolic path is the record of a journey too vast for us to trace, the evidence of histories we cannot reconstruct. To watch Atlas move along its highway is to glimpse a fragment of galactic motion written across the sky, a reminder that we are part of a network far larger than ourselves. The story continues not in what Atlas is, but in what it represents. A body from elsewhere, travelling a path we cannot follow, carrying within it chemistry we do not fully understand. Hyperbolic highways guarantee that it will leave us soon, but they also guarantee that others will follow. The galaxy ensures this through sheer scale. The highways are crowded, the intersections endless, and the traffic unstoppable. We're only at the beginning of seeing it. Every time an interstellar object passes through our system, it arrives carrying silence. No transmissions, no signals, no engineered signatures. Just a cold body of ice, dust and rock gliding along a path carved by gravitational chance. To science, these are natural leftovers of star formation, relics of ancient collisions, frozen debris ejected billions of years ago. To the speculative imagination, however, that silence is its own kind of message. A whisper between stars, faint and easily overlooked but persistent in its repetition. For the third time in less than a decade, we have watched one of these messengers pass. 3 visitors, 3 silences, 3 reminders that we are not alone in the galaxy, even if what we meet is only fragments of alien stone. The metaphor of a whisper is fitting because of scale. These objects are small, perhaps only a few hundred meters across, lost in the immensity of interstellar space. Against the backdrop of stars, they are dust motes drifting in endless dark. Yet when they pass near our sun, they shine just enough to be noticed. The whisper is not loud, not clear, but distinct enough to catch our attention, and once noticed it cannot be ignored. Each one says something, though what it says depends on interpretation. Science hears the voice of planetary formation, evidence that other systems formed planets like ours, ejecting debris into the galaxy. Speculation hears something else, the possibility that whispers are intentional, signals disguised as silence, presence hidden in plain sight. Atlas, like its predecessors, spoke in chemistry. When spectra revealed its high ratio of carbon dioxide to water, the numbers startled researchers. Such a composition was unlike comets in our own solar system, suggesting a very different history. Perhaps it formed in a system richer in carbon, or under colder conditions where carbon dioxide ice dominated. Whatever the explanation, its chemistry was a message from another environment, encoded not in language, but in molecular ratios. This is the kind of whisper interstellar messengers carry. Not words, but data. Not intention, but information embedded in their makeup. To read such a message requires instruments, patience, and imagination. But silence is ambiguous. To interpret chemical fingerprints as messages is to stretch meaning. A comet does not intend to tell us anything. It simply is what it is, and we interpret. Yet humans are pattern-seeking creatures, and silence itself invites speculation. What if the absence of obvious signals is the signal? What if the message lies in the very fact of arrival, in the repetition of visitors, in the rhythm of three? Silence becomes voice when repeated often enough. It is the whisper that says again and again, "We are here, we exist, we move among you." Whether that "we" is natural processes or something more deliberate is left for us to decide. The idea of messengers disguised as comets is not new. Carl Sagan and other thinkers once speculated that advanced civilizations might use natural bodies as carriers, embedding technology within them, letting them drift along natural highways. A disguised probe would look no different from debris, perfectly camouflaged among trillions of others. Its silence would not be evidence of absence but of intention. Such an idea hovers at the edge of speculation, because while evidence is lacking, the logic is compelling. If you wish to travel unnoticed, why not travel in silence, hidden among the whispers of countless natural bodies? The galaxy itself seems built for such whispers. Distances between stars are so vast that deliberate signals are easily drowned in the cosmic background. A beam of radio may travel, but it weakens, it disperses, it risks never being received. Matter, by contrast, persists. A comet ejected into interstellar space remains intact for billions of years, carrying whatever was placed inside. In this sense, comets are natural couriers, silent messengers whose endurance outlasts civilizations. If anyone wanted to send whispers across the galaxy, comets and asteroids would be the vessels, silent, unremarkable, eternal. This line of thinking is speculation, and most astronomers resist it. For them, the whisper is chemistry, nothing more. Each interstellar object provides data about environments we cannot visit. Each is a messenger not of intention, but of nature, carrying the imprint of alien stars in its frozen molecules. Atlas told us of carbon-rich conditions. Borisov told us of cometary activity much like our own systems. Oumuamua, enigmatic as it was, told us that shapes and dynamics can differ in ways we did not predict. Each whisper broadens the story of how stars and planets form. Each expands our knowledge of what is possible. That is enough for science, and it is not insignificant. Yet silence carries weight because of what it does not resolve. The whispers come without context, without explanation. We receive them as fragments, incomplete sentences from an unknown author. Incomplete messages provoke imagination. If we detected only one, the silence might have been easy to dismiss. With 3, the silence grows louder, pressing against our awareness. We know now that interstellar messengers exist. We know they arrive more often than expected. We know they carry compositions different from what we see at home, but we do not know their full story, and silence leaves that gap wide open. The idea that silence itself is a message resonates with another tradition in astronomy: the search for extraterrestrial intelligence. For decades, radio telescopes have scanned the skies listening for signals. So far, nothing unambiguous has been found. Silence has been the result. This silence has been interpreted in many ways. Perhaps civilizations are rare, perhaps they are short-lived, perhaps they choose not to transmit. The whispers of interstellar objects fit into this framework. They are another kind of silence, another form of absence that might conceal presence. The absence of radio is not the absence of intelligence, and the absence of anomalies and comets may not be either. Silence is information, though difficult to decode. Consider how easily silence can mislead. When pulsars were first discovered, their regular radio pulses were dubbed LGM, short for little green men. The signals were so regular, so artificial seeming, that intelligence was the first thought. Only later did we learn they were natural, rotating neutron stars. The lesson was that what appears artificial can be natural. But the inverse may also be true. What appears natural may be artificial. If a civilization wished to hide its presence, silence would be the strategy. A probe disguised as a comet, carrying no signals, emitting nothing, would blend perfectly. Silence becomes cover. Silence becomes safety. For now, we cannot prove that Atlas or its predecessors were anything but natural, but we can acknowledge that silence invites these questions. Each interstellar object is a silent messenger in its own way, not because someone sent it, but because its arrival forces us to interpret. The whisper is not in what it carries, but in what it makes us ask. Why here? Why now? Why 3 in such a short span? Silence forces speculation because humans cannot help but assign meaning. There is another dimension to the whisper: time. These objects move on scales beyond human history. Atlas may have been drifting for billions of years before it passed near our sun. Its silence has lasted longer than humanity itself. To encounter it now is coincidence beyond comprehension. The whisper is not directed, not aimed, but received by chance. And yet, to those who encounter it, the timing feels like message. The fact that we see it now, at the moment when our instruments can detect it, gives the silence weight. It feels as if the galaxy has begun to speak, not loudly, but faintly, in a language we barely recognize. This sense of timing is part of why whispers unsettle. If we had not developed wide-field telescopes, Atlas would have passed unnoticed. Silence would have remained unbroken. That we notice now, just as our civilization becomes capable of listening, feeds the sense that something is unfolding. Perhaps it is only the natural consequence of technological progress. But perhaps not. Perhaps silence has waited for us to be ready. The whisper arrives at the moment when ears exist to hear it. When astronomers report these findings, they speak in terms of discovery, of catalogue numbers and orbital parameters. The language is technical, precise, careful. Yet beneath that language lies the deeper resonance. Each new interstellar object confirms that the galaxy delivers whispers, that we are part of a system open to messages we cannot fully read. The technical reports are one layer, the cultural and philosophical implications another. Silence becomes a canvas onto which we project our hopes and fears. Silent messengers force us to confront what it means to be noticed, or to notice in a galaxy we cannot yet traverse. Atlas will fade soon, like its predecessors. Its brightness will diminish. Its path will carry it outward, and it will vanish back into the dark. The whisper will end, leaving behind only data, spectra, and orbital plots. But the memory will linger, and with it the expectation of more whispers to come. Each one will repeat the silence, each one will remind us of our place, each one will whisper that the galaxy is not empty. Whether these are natural fragments or hidden probes, whether they are messengers of geology or of intelligence, the effect is the same. Silence presses on us, forces us to imagine, compels us to prepare for the next arrival. And the next will come. The highways guarantee it. The galaxy is full of messengers, drifting in silence, waiting for the chance intersection that brings them near our sun. We will listen again, we will measure again, we will interpret again. The whisper between stars will continue, and we will continue to wonder whether we are listening to the voice of nature or the breath of something greater. The silence is never empty. It is always speaking, always reminding, always unsettling. When Oumuamua first appeared, it felt singular. The first confirmed interstellar object ever seen, the first undeniable proof that fragments from other stars truly cross into our solar system. The excitement was tempered by its elusiveness. Detected late, already on its way out, Oumuamua left behind more questions than answers. Its elongated shape, its strange brightness variations, its unexplained acceleration, all of it resisted clean explanation. Natural models were offered, some plausible, none definitive. Speculation bloomed, from hydrogen icebergs to artificial sails. It was one visitor, one anomaly, one unsolved puzzle, destined perhaps to remain a curiosity in astronomical history. 2 years later, Borisov arrived and shifted the narrative. Unlike Oumuamua, it displayed all the expected hallmarks of a comet: a coma, a tail, outgassing clearly visible in telescopes. Its chemistry and activity confirmed that it was truly from interstellar space, but in every other respect it looked familiar. Where Oumuamua had unsettled, Borisov reassured, it proved that interstellar visitors need not be strange. They could be ordinary comets, indistinguishable from the billions of icy bodies in our own system. In this sense, Borisov normalized the idea of interstellar comets. The phenomenon was no longer singular. It was repeatable, observable, expected. Now, with Atlas, the sequence begins to take shape. This third object combines features of both its predecessors. Like Oumuamua, it is unusual, chemically distinct, pushing against the boundaries of known cometary behaviour. Like Borisov, it still fits broadly within natural categories, its outgassing and composition consistent with cometary physics, even if strange in detail. Together the three form not just a list of anomalies but a sequence, a progression that reshapes our understanding of what to expect from the galaxy. Beyond Oumuamua and Borisov lies the recognition that these objects are not isolated flukes. They are part of a larger population, and their diversity hints at a galaxy far more complex than we imagined. The emerging sequence matters because it reframes probability. A single detection could be dismissed as chance. 2 in short succession raised eyebrows but could still be coincidence. 3 in less than a decade changes the equation. It suggests that interstellar visitors are not rare, not once in a civilization events, but regular features of the cosmic environment. If we have seen 3 so quickly, we will likely see dozens more in coming decades. The sequence reveals itself not only in the objects themselves, but in the inevitability of future discoveries. Each object adds to the pattern in its own way. Oumuamua was enigmatic, Borisov was ordinary, Atlas was both. The sequence emerges not as repetition but as variety, and that variety is telling. It suggests that interstellar space is not populated by uniform bodies, but by a wide distribution of compositions, shapes, and behaviours. Some will look familiar, others alien. Each one is a sample of a different star's debris, a piece of geology from another system. Collectively, they form a catalogue, a record of planetary formation across the galaxy. In this sense, the sequence is not just of objects, but of stories. Each one tells us something about where it came from, even if the details are incomplete. But variety also fuels speculation. If the first was anomalous, the second familiar, and the third anomalous again, what will the fourth be? Will the sequence continue to alternate? One strange, one ordinary, one strange again? Or will the anomalies accumulate, each new visitor stranger than the last? The idea of a sequence carries with it the expectation of continuation. Once patterns are recognized, the mind expects them to repeat. And when repetition occurs in matters as vast as interstellar visitors, the sense of narrative grows stronger. It begins to feel like progression, like escalation, even if the underlying cause is only randomness. The scientific community frames the sequence as evidence of detection capabilities. Telescopes are finely sensitive enough, surveys wide enough, computers fast enough. What seemed extraordinary is merely the result of better vision. In this frame, the sequence is not cosmic design, but human achievement. We are seeing what was always there. Yet even within this explanation, the implications are profound. If interstellar objects are this common, then our solar system is more connected to the galaxy than we thought. Material does not remain confined to its birth star. It drifts, it wanders, it crosses boundaries. The sequence of 3 is proof that our neighbourhood is open, that exchanges between systems happen constantly, that the galaxy is one environment, not many isolated islands. This openness feeds into larger questions about panspermia, the possibility of life spreading through interstellar debris. If comets and asteroids can travel between stars, then so can the ingredients of life. Amino acids, organic molecules, even hardy microbes in theory could hitch rides across light years, embedded in protective shells of ice and rock. The sequence of visitors is not just geological, it may be biological. Each interstellar comet could carry seeds of chemistry, whispers of life from systems we may never see. Beyond Oumuamua and Borisov, the sequence suggests that such exchanges may be routine. Life may not be isolated to one world or one star. The galaxy may be a shared environment, connected by silent messengers that drift endlessly. Yet the speculation cuts the other way as well. If intelligence exists elsewhere, it too might notice the sequence. It too might recognize that interstellar objects provide perfect cover. Beyond Oumuamua and Borisov lies the possibility that one of these messengers might not be natural at all. The disguise would be flawless, indistinguishable from debris, unremarkable to telescopes. The silence of interstellar objects makes them ideal for stealth. This possibility remains speculative, unsupported by evidence, but the sequence forces us to keep it in mind. 3 arrivals suggest more to come, and with more arrivals come more chances for anomalies that cannot be dismissed. Another way to view the sequence is through history. Scientific revolutions often begin with anomalies. A single anomaly can be explained away. A second may be ignored. A third begins to demand attention. Patterns of anomalies accumulate until old models collapse and new ones emerge. The sequence of interstellar objects may be the beginning of such a shift. For centuries we believed the solar system was a closed environment, comets and asteroids bound by the sun's gravity. Now we know that fragments from elsewhere pass through. Already the old model is gone. With each new discovery, the sequence pushes us further, toward models that treat the galaxy as interconnected, dynamic, constantly exchanging material. The shift is only beginning, and the sequence is the evidence. For now, we're at the early stage. 3 visitors, 3 data points. Too few to draw conclusions with certainty, but enough to suggest direction. Beyond Oumuamua and Borisov, the sequence emerges as inevitability. More will come. Each one will be studied, measured, debated. Each one will add to the pattern. Over time, the sequence will reveal whether interstellar objects are mostly ordinary or mostly strange, whether our first 3 were typical or exceptional, whether anomalies are the rule or the exception. The answers will not come quickly, but they will come, delivered object by object, whisper by whisper, along the highways that crisscross the galaxy. The sequence also challenges us to think about preparedness. If visitors are inevitable, should we be ready to intercept them, to send spacecraft to sample them directly, to capture fragments of alien geology before they vanish back into the dark? So far, we have not been ready. Oumuamua passed before missions could even be designed. Borisov moved too quickly for interception. Atlas II will escape beyond reach. But in the future, the sequence may demand more. If such objects arrive regularly, then humanity faces a choice: watch them pass or meet them in space. To do the latter will require foresight, planning, and a recognition that the sequence is not random noise but opportunity. Beyond Oumuamua and Borisov, Atlas shows us that we are entering a new era. The age of interstellar detection, the age of galactic context. Each visitor adds to the story, each one part of a sequence that is only beginning to unfold. Whether this sequence is coincidence, countdown, or revelation remains to be seen. What matters is that it exists, that it continues, that it forces us to look beyond the local and accept that we are part of something larger. The sequence is the message. The galaxy has begun to reveal itself object by object, and we are listening. Every interstellar object that passes through our solar system brings with it the same tension. On the surface, there is nothing extraordinary about a fragment of rock and ice flung from another star system billions of years ago. Celestial mechanics makes clear that such fragments should exist in enormous numbers. With trillions of planets and protoplanetary disks forming across the galaxy, the ejection of debris is inevitable. Hyperbolic orbits are expected, wandering bodies are expected, and the occasional passage through our neighbourhood is expected. Yet the more we observe, the more that simple expectation begins to feel insufficient. We have now seen 3 confirmed visitors in less than a decade, each one unique, each one whispering a different message through its chemistry and its trajectory. And the question grows louder. What if this is not just chance? What if these are not merely fragments of nature, but part of something larger? What if we are being measured? The idea of reconnaissance is unsettling precisely because it does not require contact. If a civilization wanted to observe others, it would not need to announce itself. It would not need to land ships, broadcast signals, or risk confrontation. It would only need to gather information. Reconnaissance is quiet, distant, and effective, and if it were to be done on a galactic scale, the most efficient strategy would be to use what already exists: the endless population of comets and asteroids drifting through interstellar space. Each one could serve as a courier, a probe disguised as a natural object, indistinguishable from debris. No need to send fleets, no need to reveal presence. Just let the galaxy itself deliver the instruments, and let those instruments measure, record, and pass silently onward. This is only theory, and science remains cautious. There is no evidence that Oumuamua, Borisov, or Atlas were artificial. Their orbits followed physics. Their spectra revealed chemistry consistent with natural origins, and no signals were detected. But reconnaissance theories persist because they exploit a possibility that cannot be ruled out. The very features that make interstellar objects ordinary are what make them perfect for disguise. If you wanted to watch without being noticed, you would want your probes to look exactly like the natural bodies astronomers expect to see. Silence, irregular shapes, cometary activity. These would all be camouflage, not anomalies. To ask whether we are being measured is to confront human vulnerability. We're used to thinking of ourselves as observers. For centuries, astronomy has been a one-way act. We build telescopes, we study the skies, we measure light from stars and galaxies. The idea that something might be observing us reverses the direction. We become the subject of measurement rather than the measurers. And interstellar objects are the perfect symbol of this reversal. They appear unexpectedly. They cross our space. They leave without explanation. They could be messengers, they could be scouts, or they could be nothing more than wandering stones. But each arrival forces the same uncomfortable thought. What if their passage is not random? Theories of cosmic reconnaissance vary in scope. The simplest suggest passive measurement. A probe disguised as a comet could record electromagnetic emissions, atmospheric chemistry, or even technological signatures as it passes. It would not need to land, it would not need to interact, it would only need to observe. In this sense, we might already be measured, catalogued and forgotten, our presence noted in databases carried across the galaxy. Another version imagines active measurement. Objects might release signals we have not yet learned to detect, or they might carry encoded information in their chemistry, subtle ratios designed to be recognized once our instruments become advanced enough. Still more speculative is the idea of long-term monitoring. Probes could seed themselves in stable orbits, disguised as comets or asteroids, waiting silently while they watch across centuries. Skeptics argue that such theories are unnecessary. The distances between stars are immense, the energy costs of interstellar travel extreme, the likelihood of civilizations overlapping in time low. They argue that natural explanations suffice, that interstellar objects are expected and do not require intelligence to explain. Yet the theories persist because intelligence is also expected. If life arose here, it could arise elsewhere. If we measure, others could too. Reconnaissance is a natural impulse for any civilization seeking knowledge. And in the absence of clear evidence, speculation thrives in the gaps. The strongest argument in favour of reconnaissance theories is efficiency. Natural objects already exist in numbers too large to count. To embed instruments within them would be a strategy of elegance. No need to launch vast fleets of probes, no need to reveal intention. Just use what is abundant and let the galaxy's natural highways deliver them. For us, the idea is speculative. For a civilization millions of years older, it might be obvious. In this frame, the question is not whether reconnaissance is possible, but whether it is already happening, unnoticed, in plain sight. If we are being measured, what is being measured? At minimum, the composition of our atmosphere would reveal much. Oxygen levels betray biology. Industrial gases betray technology. Radio leakage betrays communication. A passing probe would not need to land to gather this data. A simple spectral analysis from within our system would suffice. In this sense, humanity may have already been catalogued. Long before we developed radio telescopes, long before we wondered whether anyone was watching, our planet may have been marked as inhabited, as technological, as worth noting. Reconnaissance does not require interaction. It only requires measurement. This possibility reframes our place in the galaxy. We often imagine ourselves waiting for first contact, listening for signals, scanning for signs. But if reconnaissance is real, then first contact may have already occurred. Not in the form of greetings, but in the form of being observed. We may already exist in someone else's records, one entry among countless others, measured and stored without our knowledge. The silence we interpret as absence may instead be strategy, the deliberate choice not to reveal. In that frame, interstellar objects are not just rocks. They are reminders of our potential exposure. Each one could be a probe, each one could be watching. But the ambiguity is the heart of the matter. We cannot know. Every spectrum, every orbit, every observation so far points to natural explanations, and yet none of it can prove that intelligence is absent. Theories of cosmic reconnaissance live in that space between certainty and speculation. They are not claims, but questions. What if the silence is intentional? What if the camouflage is perfect? What if the galaxy already measures us quietly, routinely, without revealing its hand? For now, these remain questions without answers. Science proceeds with caution, cataloguing each new interstellar object, refining orbital models, studying chemistry. No signals, no evidence of engineering, no deviations from physics. Everything points to natural origins. Yet each new visitor reopens the question, and the repetition makes the question louder. 3 in less than a decade. 3 opportunities for measurement, 3 silences that may be ordinary or may be deliberate. Theories of reconnaissance gain traction not because of evidence, but because of accumulation. The more we see, the more we wonder. The question of being measured is not only about astronomy, it touches psychology, culture, and philosophy. To imagine ourselves as subjects of reconnaissance forces us to confront vulnerability. We're not in control of who passes through, we're not in control of what is measured, and we may never even know it has happened. That helplessness is unsettling, and it fuels both fear and fascination. Are we safe because silence continues, or are we simply unaware of what has already occurred? Are we alone, or are we already part of a catalogue too vast to comprehend? In the end, the theories remain just that, theories, but they matter because they expand the conversation. To ask whether we are being measured is to acknowledge the possibility of intelligence beyond ourselves. To ask whether interstellar objects could serve as probes is to recognise the ingenuity of strategies we might one day use ourselves. And to confront the silence is to admit that absence of evidence is not evidence of absence. Theories of cosmic reconnaissance remind us that what we see may not be all that exists, and that the galaxy may hold secrets beyond our detection. Oumuamua, Borisov and Atlas were likely natural, and yet the very possibility that they were not keeps the question alive. Were they just wanderers, or were they whispers with purpose? Theories of reconnaissance will not be settled by speculation. They will be settled by evidence, if evidence ever comes. Until then, each new visitor will carry the same unease, the same whisper, the same possibility that we are not the only ones watching. The discovery of Oumuamua, Borisov and Atlas has forced us to confront an uncomfortable realization. Our solar system is not a closed environment, bounded and secure. It is porous, open to a steady stream of wanderers from elsewhere. The idea of interstellar traffic was once theoretical, a statistical inevitability based on models of planetary formation. Now it is observational reality. 3 confirmed visitors in less than a decade suggest not rarity but routine. And that raises a deeper question. What exactly is this traffic? Are we witnessing the random flow of natural debris, fragments flung from other stars in ancient acts of violence, or could there be something more deliberate at work? Is the galaxy's hidden traffic merely the byproduct of chance, or is there design in its patterns? The first explanation is the simplest, and it rests on scale. Planetary formation is chaotic. When young stars gather disks of dust and gas, gravity acts with ruthless efficiency. Planets accrete, moons form, collisions occur, and much of the leftover material is destabilized. Giant planets in particular serve as slingshots, ejecting vast numbers of icy planetesimals into interstellar space. Over billions of years, this process repeats in system after system. The result is a galaxy saturated with debris. Trillions upon trillions of fragments wander endlessly, unbound to any star, following hyperbolic paths shaped by random encounters. Against such numbers, the fact that a few cross our solar system each decade is not surprising. It is inevitable. The hidden traffic is simply the background noise of creation, the silent consequence of how planets are born. From this perspective, there is no mystery. Oumuamua was one of countless rocky shards. Borisov was one of countless comets. Atlas is one of countless icy fragments. The fact that we have only just begun to notice them reflects the limitations of our technology, not the rarity of the objects themselves. The traffic has always been there. Only now do we have the tools to glimpse it. Wide-field surveys, automated detection, and powerful telescopes finally reveal what has always existed. To argue otherwise, many scientists say, is to underestimate both the galaxy's scale and our own blindness until recently. But once the door is open, other possibilities slip in, because traffic implies motion, and motion invites interpretation. If trillions of fragments cross the galaxy, then selection matters. Which ones pass near us? Which ones become visible? Which ones carry anomalies? The randomness of debris does not erase the possibility of design. In fact, it may provide cover for it. If a civilization wished to move unnoticed through the galaxy, it could hide among the traffic. It would not need to create new vessels, only to embed within existing ones. Debris offers camouflage, and camouflage thrives in abundance. This is where speculation takes hold. The hidden traffic of the galaxy may be more than geology in motion. It may also be opportunity. Each wandering fragment is a courier of chemistry, carrying molecular fingerprints from alien stars. But each could also, in theory, be a courier of intention. A probe disguised as a comet, a monitor hidden in an asteroid, an engineered body designed to look natural but to perform tasks beyond our detection. In this light, the galaxy's traffic becomes a dual system, natural debris providing the cover and perhaps within it artificial design. The idea of design does not rest on evidence. No interstellar object has shown clear signs of engineering. But the theory persists because of plausibility. The galaxy is too large for direct oversight. Civilizations, if they exist, must find efficient ways to explore, to monitor, to measure. Embedding instruments within naturally occurring debris solves both the problem of concealment and the problem of endurance. Natural objects can survive billions of years in interstellar space. They carry no signatures of propulsion, no signals that draw attention. They are accepted as natural, even when noticed. If design exists, it would be indistinguishable from debris unless extraordinary evidence revealed it. This duality, debris or design, creates unease. On the surface, every interstellar object we have seen fits natural explanations. Yet the possibility of design hovers in the background because silence itself is ambiguous. When Atlas revealed an unusual ratio of carbon dioxide to water, astronomers explained it through natural variation. But a speculative mind wonders, could that ratio itself be a code, a marker meant to be noticed? When Oumuamua accelerated without a visible coma, models involving outgassing were proposed. But some argued the acceleration was too precise, too clean, raising questions about artificial propulsion. When Borisov looked ordinary, it reassured, but it also suggested that if design existed, it would need to mimic the ordinary perfectly. The hidden traffic of the galaxy magnifies these questions because it forces us to confront scale. If trillions of fragments wander, then trillions of opportunities exist for both natural encounters and deliberate ones. To say that none of them are designed is to assume that no civilization has ever used the strategy. To say that some might be designed is to admit that we may never be able to tell. The ambiguity is permanent, and in that ambiguity lies the tension. We see the traffic, but we do not know what rides upon it. Another dimension emerges when considering panspermia. Natural debris may not only carry geology but biology. Comets are rich in organics, amino acids and volatiles. If life arose elsewhere, fragments of it may have been carried into interstellar space, drifting silently until they encounter other systems. In this frame, the hidden traffic is not inert but alive, or at least life-bearing. The galaxy becomes not just a scattering of stars but a network of exchanges, where seeds of life pass between systems. If design is not present, purpose may still exist, embedded not by intelligence but by biology itself. The traffic becomes a conveyor of possibility, spreading the raw ingredients for life wherever it goes. And if that is true, then the distinction between debris and design begins to blur. Natural fragments spreading life are not engineered, but they achieve something that looks like purpose. They carry potential across vast distances, bridging the isolation of stars. If intelligence ever arises, it does so against the backdrop of this traffic. In that sense, every civilization is already a product of it, whether or not it ever chooses to exploit it deliberately. The hidden traffic may be both debris and design simultaneously. Debris in origin, design in effect, shaping the galaxy in ways no one intended but that no one can ignore. For now, the scientific stance remains grounded. The traffic is debris. We are just beginning to notice it. More will come. Each will expand our understanding of planetary formation. Each will enrich our catalogue of alien chemistry. But even scientists acknowledge that the hidden traffic carries mysteries. Why was Oumuamua so odd? Why was Borisov so normal? Why is Atlas chemically extreme? These differences resist simple categorization. The sample is small, but variety already dominates. The more we observe, the more the hidden traffic looks less like background noise and more like a spectrum of possibilities. And within that spectrum, speculation about design persists because the differences invite it. In cultural terms, the hidden traffic challenges how humanity thinks of itself. For centuries, we imagined the solar system as a bounded space, stable, predictable, cyclical. Now we see it as a crossroads. Objects enter and leave. Visitors pass silently. We are part of a network, whether we want to be or not. That network may be random, it may be purposeful, it may be both. But it is not absent. The hidden traffic exists, and it will continue whether we pay attention or not. That realization is both humbling and unsettling. Ultimately, debris or design may not be a binary choice. The galaxy may contain both. Most of the traffic is likely natural, the inevitable consequence of planetary formation. But hidden among trillions of fragments, the possibility of design cannot be excluded. If civilizations exist, they would see the same opportunity we do. They would know the same strategy. And if they acted upon it, we might never know. The traffic would look the same, sound the same, move the same. Silence would cover everything. Only anomalies might betray it. And even then, interpretation would remain contested. This is where we stand. We see the hidden traffic of the galaxy. We measure it, we catalogue it, we interpret it. We call it debris because that is the simplest explanation, and it may well be correct. But the possibility of design shadows the explanation, unprovable, unrefutable, persistent. Each new visitor adds to the tension, each one reminding us that debris and design may be indistinguishable when viewed from afar. The traffic continues, and with it the question, what passes among us unnoticed along the highways of the galaxy? When we speak of interstellar objects, we often imagine them as recent travellers, flung from alien stars and arriving here by chance. But in truth, many of these wanderers may be unimaginably old. Some of them could have been ejected from their home systems billions of years ago, long before Earth itself even existed, long before the sun ignited as a star. Their journeys are not measured in centuries or millennia, but in epochs that defy human scale. These ancient wanderers drift in silence across the galaxy, their paths altered by gravitational tides, their surfaces weathered by cosmic rays, their interiors preserving secrets from times when the galaxy itself was young. To encounter one is not merely to see a fragment of another star system. It is to touch history older than our planet, older than our biosphere, older than the human concept of history itself. That age carries implications we rarely dwell on. A fragment ejected from a young star system 5 or 10 billion years ago may have travelled ever since, crossing interstellar space without direction, without purpose, but not without meaning. Its chemistry preserves conditions that no longer exist. Its isotopes record environments that may have been erased by time. In this sense, every ancient wanderer is a time capsule, a messenger not only from another place but from another era. Studying one would give us glimpses of what the galaxy was like before humanity, before Earth, before even the sun. Each one is a relic of galactic antiquity, carrying within it the fingerprints of vanished worlds. The intentions we ascribe to such wanderers are our own. Rocks do not plan, comets do not decide, debris does not choose where it travels. Yet once we acknowledge that these objects may be billions of years old, another thought intrudes. If intelligence has ever arisen in the galaxy before us, it may have arisen billions of years ago. Civilizations could have risen and fallen long before our species appeared. If so, then some of these wanderers may not be merely natural relics. They could be relics of intention. An ancient civilization with the ability to manipulate matter on a planetary scale could have embedded probes, messages, or artifacts within interstellar bodies, using them as carriers that would endure long after the civilization itself was gone. In this frame, ancient wanderers may carry ancient intentions, the last surviving traces of intelligence long extinct. This possibility forces us to reconsider what we mean by discovery. We often imagine contact as something alive, present, immediate. But contact with the galaxy may instead be archaeological. To find evidence of intelligence may not mean dialogue with contemporaries. It may mean uncovering fragments left behind, relics drifting in silence for billions of years, their creators gone, their purposes forgotten. Ancient wanderers become tombstones of civilizations, their intentions unreadable, their messages indecipherable, but their existence undeniable. The galaxy could be filled with such ruins, carried on hyperbolic highways, arriving in our solar system as comets we dismiss as natural. Skeptics remind us that no evidence exists to support this vision. Oumuamua, Borisov and Atlas all fit within natural categories, however unusual. Their chemistry and motion can be explained without invoking intelligence. But skepticism does not erase possibility. The timescales involved are too vast, the number of wanderers too large. To assume that none carry ancient intentions is to assume that intelligence has never arisen before us, or that no civilization ever chose to exploit the strategy. That may be true, but it may not. The absence of evidence is not proof of absence, and each visitor leaves the question unresolved. There is also the unsettling thought that if ancient intentions exist, they may not be benign. A probe embedded in a comet billions of years ago might not care whether the civilization it encountered was ready, safe, or fragile. It may not care whether life here was microbial or intelligent. It may simply observe, record, or activate when conditions are met. We imagine intention as purposeful, directed, considerate. But ancient intentions may not resemble human reasoning. They may be automated, indifferent, relentless, acting according to goals set long before humanity appeared. Contact with such a probe would not be dialogue. It would be discovery of machinery whose purpose we cannot alter. Even if no artificial intentions exist, the wanderers themselves shape the galaxy in ways that resemble intention. By transporting organic compounds, by scattering amino acids, by carrying volatiles, they may have spread the seeds of life across stellar systems. This is panspermia, the idea that biology is not confined to one world but distributed across many, carried by comets and asteroids. In this frame, the ancient wanderers have already fulfilled an intention of sorts, not by design but by consequence. They spread potential wherever they go. Life on Earth may itself be the result of such delivery. If so, then every interstellar object that passes us is kin, a relative that shares the same galactic heritage. The intentions may not be conscious, but the effects are profound. This duality, wanderers as relics of natural history or carriers of ancient design, defines our unease. With each visitor, we are reminded that we cannot easily tell the difference. Natural chemistry can mimic code. Random shapes can mimic craft. Silence can conceal as effectively as it can reveal, and age compounds the problem. A probe billions of years old would not look like the technology we imagine. It might not emit signals. It might not function in ways recognizable to us. It might be eroded to stone, disguised perfectly by time. Ancient intentions could be invisible precisely because of their antiquity. The weight of age also reshapes the narrative of coincidence. 3 interstellar objects in less than a decade feels sudden, almost like a pattern. But from the perspective of billions of years, it is nothing. The galaxy has been sending wanderers through our solar system for longer than Earth has existed. we're only now capable of noticing. In that sense, the intentions we ascribe may not belong to the objects at all. They belong to us, to the fact that our awareness has matured at this precise moment. The wanderers are ancient, but our noticing is new. Their silence has lasted for eons. Our interpretation is the recent intrusion. Still, the thought of ancient intentions refuses to fade. It is not only science fiction that entertains the idea. Serious thinkers in SETI and astrobiology acknowledge that if probes exist, they may not be contemporary. They may be relics, placed long ago, waiting silently, unnoticed. The Fermi paradox, the question of why we do not see evidence of others, may find one answer here. We do not see them because they are not alive. What remains are ruins, drifting in interstellar space, indistinguishable from comets, silent, ancient. If so, then every hyperbolic visitor carries the possibility of being more than geology. Each one could be an artifact of lost civilizations, their intentions unknowable, their presence undeniable. This perspective reframes our relationship with discovery. It suggests that when we look to the skies, we're not only studying physics but archaeology. Every spectrum, every orbit, every chemical ratio is a fragment of a larger history. We are digging through the galaxy's ruins, whether or not we recognize them as such. Ancient wanderers may be natural debris, but they may also be artifacts, relics, or carriers of forgotten intentions. The ambiguity is permanent because without direct interception we cannot know, and interception, with our current technology, remains beyond reach. As the sequence of interstellar discoveries continues, the weight of this ambiguity grows. Each new object is a test of interpretation. Do we assume debris, or do we remain open to design? Do we see only geology, or do we consider archaeology? Do we acknowledge the possibility of intention, even if we cannot prove it? These are not scientific questions alone. They are cultural, philosophical, existential. They shape how we see ourselves in the galaxy. Are we alone in a sea of debris, or are we latecomers in a galaxy where intentions have already been scattered and forgotten? For now, the safest assumption is debris. Science demands evidence, and evidence points to natural explanations. But ancient wanderers by their very nature resist certainty. They are older than our planet, older than our species, older than our science. Their silence cannot be taken as proof of emptiness. Ancient intentions may exist within them, hidden, dormant, unreadable. Or they may not. The only certainty is that the wanderers will continue to come, and with each arrival the question will return. Are we watching history, or are we being watched by history itself? When we look at interstellar visitors, we tend to see them as isolated events. A comet here, an elongated rock there, each one arriving alone, each one passing and vanishing into the dark. But patterns have a way of reshaping perspective. 3 visitors in less than a decade hint at repetition, and repetition hints at structure. Once structure is suspected, another idea emerges. What if these objects are not isolated at all? What if they are part of something larger? What if the interstellar traffic we have begun to glimpse is not only random debris but components of a network? What if each object is not just a wanderer, but a node in a web stretched across the galaxy? The possibility of such a network is difficult to dismiss because it draws on analogies from our own history. On Earth, networks form naturally. Rivers branch and merge, trade routes develop, communication systems evolve, and eventually every society we have built becomes connected by pathways of movement and exchange. It is natural for intelligence to extend its reach by creating links. If civilizations exist elsewhere, the same principle might apply. A galaxy filled with countless interstellar objects provides the infrastructure. Each comet or asteroid could serve as a waypoint, a storage site, or a courier. No massive fleets required, no grand visible structures, just a quiet web built from what the galaxy already provides. The simplest version of this theory imagines storage nodes. A civilization could embed information, instruments, or technology within natural bodies, releasing them into interstellar space. Over time, those bodies would spread throughout the galaxy, some passing close to stars, others remaining in deep interstellar dark. The network would not be fast. Messages would not travel at the speed of light, but at the slow drift of celestial mechanics. Yet speed may not matter to civilizations that think in terms of millions of years. What matters is persistence. A network built on interstellar debris could endure as long as the galaxy itself. Another version imagines waypoints, like lighthouses along shipping routes. Natural objects travelling on hyperbolic paths could be used to map safe passages, to test gravitational corridors, or to mark regions of interest. If intelligence sought to cross the galaxy, it would not move blindly. It would need guides, markers, and references. What better way to build such a system than to use the objects already in motion, embedding within them signals or instruments that allow navigation? Each object becomes a node in a galactic positioning system, a silent beacon disguised as a rock. More ambitious is the idea of communication networks. Interstellar objects might carry stored messages designed to be read by any civilization advanced enough to detect and study them. The galaxy may be too vast for active broadcasting to be reliable, but passive distribution could succeed if billions of objects wander, and if even a small fraction carry encoded information, then any technological species that develops astronomy will eventually encounter one. The network in this sense is not for communication between civilizations, but for communication to them, a galactic library scattered like seeds waiting to be found. Each object a node, each node a message, each message a fragment of a larger whole. Skeptics point out that no evidence for such a network has been found. Oumuamua carried no obvious signals, Borisov looked entirely natural, and Atlas revealed only chemical anomalies explainable by natural variation. If there is a network, it is invisible. But invisibility is exactly what a durable system would require. For such a network to persist, it would need to blend with nature perfectly, avoiding detection by those not ready to understand. Camouflage would not be a flaw, it would be the design. Only civilizations capable of detailed study would even suspect its existence, and even then certainty might be impossible. The very plausibility of the idea lies in its undetectability. The thought of such a network reframes the three interstellar objects we've seen so far. Instead of treating them as isolated anomalies, we can imagine them as samples of nodes, each one distinct, each one part of a wider distribution, each one carrying information in its differences. Oumuamua's odd acceleration, Borisov's cometary activity, Atlas's unusual chemistry, perhaps the anomalies themselves are signals, not intentional in the way we understand, but meaningful when placed together. A single node says little. A series may reveal a pattern. We may simply not yet have enough data to see the design. The idea of a galactic network also offers an unsettling possibility. What if the network is not for communication, but for monitoring? If intelligence exists elsewhere, it may wish to track the development of civilizations. Placing probes within interstellar objects would allow silent observation, creating a distributed surveillance system across the galaxy. Each node a watcher, each watcher silent, each silence intentional. The network in this frame is not benign. It is reconnaissance on a scale beyond our imagining, with every star system observed without knowledge. The hidden traffic becomes not random but organised, and we're not just witnesses but subjects. Even without intelligence, the concept of a network persists in natural processes. Interstellar debris creates connections between systems whether we intend it or not. Each wandering comet carries molecules from one star to another. Each one that enters a system delivers chemistry not native to it. Over time, the galaxy becomes a shared environment, interconnected by exchanges of matter. In this sense, the network already exists. It is not designed, but it functions. Systems are not isolated. They trade material through the slow motion of debris. We are part of that network already, whether or not intelligence has added to it. The challenge is distinguishing debris from design, natural network from artificial one. With only 3 confirmed objects, the sample is too small. But the very fact of those 3 suggests that more will come, and each one will add to the picture. As the catalogue grows, patterns may emerge. Patterns of chemistry, of trajectories, of anomalies. If such patterns become undeniable, then the theory of a network will move from speculation to consideration. For now, it remains a possibility, unsettling because it cannot be disproven, provocative because it fits so easily into what the galaxy already provides. This possibility also reframes our responsibilities. If objects are nodes, then interception becomes more important. Watching from a distance will not answer the question. We will need to meet them, study them directly, sample their interiors, search for signs of design hidden beneath their natural appearance. Missions like these are beyond our current capabilities, but not beyond possibility. Within decades, humanity may have spacecraft capable of intercepting interstellar objects. When that happens, the question of nodes will no longer be theoretical. We will find out whether they are only geology, or whether they carry something more. The idea of a network also speaks to human psychology. We are a species of connection, always seeking links, always imagining webs where none may exist. To see interstellar visitors as nodes may be projection. But projection itself reveals our anxieties. We fear isolation, and so we imagine networks. We fear surveillance, and so we imagine monitoring. We long for communication, and so we imagine libraries scattered across the stars. Whether or not such a network exists, the possibility speaks to what we are, to how we think about the galaxy, to what we expect from the unknown. For now, the possibility remains unresolved. The objects we have seen are most likely natural, debris without design. Yet the more we look, the more the idea persists, because it cannot be dismissed. A galactic network built from interstellar objects is both plausible and undetectable, both extraordinary and ordinary. The possibility alone reshapes how we see the visitors. They are not only wanderers, but potential nodes, and in that potential lies the unease. Each arrival may be another fragment of something larger, another piece of a web we cannot yet see, another reminder that the galaxy may be more connected than we dare to imagine. When scientists first pointed spectrographs at 3i Atlas, what they were searching for was simple. Chemical ratios, the fingerprints of molecules released as sunlight warmed the comet's frozen surface. What they found was something that stood out. The ratio of carbon dioxide to water was unlike any comet in our own solar system, unusually high, almost to the point of defying expectations. Where our local comets tend to release water vapour in abundance, Atlas released far more carbon dioxide relative to water, painting a picture of an origin environment different from anything we had previously measured. This finding did not prove anything beyond natural diversity, but it whispered of strangeness, and strangeness invites speculation. What if chemistry itself is more than geology? What if it is a kind of code? What if within the ratios of ice and dust there are signatures not only of planets and stars, but of intention? On the surface, chemistry is simple. Molecules form under particular conditions, shaped by temperature, pressure, and elemental abundance. Different systems yield different mixtures, and those mixtures survive within comets, frozen snapshots of their birth environments. When such an object passes near a star, those frozen molecules vaporize, releasing gases that can be detected across millions of kilometers. For science, this is a gift. Each interstellar visitor becomes a natural sample return mission, bringing us chemistry from stars we cannot reach. The composition is data, and the data is invaluable. But when chemistry defies expectations, when ratios fall outside the familiar, questions arise. Was this simply an odd environment, or could it mean something more? The idea of chemistry as code arises naturally because patterns matter. Humans recognize signals in ratios. We expect randomness to produce distributions, not precise alignments. If an interstellar object displayed chemical abundances that mirrored mathematical constants, or ratios resembling prime numbers, it would immediately raise suspicion. Such alignments would not be explained easily by natural processes. They would look like signatures, like messages encoded in molecules. Even without such dramatic evidence, smaller anomalies already provoke speculation. Atlas's carbon dioxide dominance may be natural, but its extremity reminds us that chemistry could be manipulated, engineered, or selected for reasons we do not yet understand. Imagine for a moment that a civilization wished to leave a message not in light or radio, but in matter itself. Comets would be the perfect medium. They travel everywhere, they endure for eons, and they carry their chemistry intact. By altering the ratios of certain volatiles, by embedding isotopic markers, by engineering mineral structures, such a civilization could write a code that would last billions of years. Any species capable of spectroscopy would eventually notice. The message would not be words, but patterns. Ratios too precise to be random, isotopes too unusual to be natural, alignments too striking to ignore. Chemistry becomes the alphabet, ice and dust the pages, the comet itself the book. Skeptics argue that this is unnecessary. The diversity of natural chemistry is already vast. Strange ratios do not require intention, only different starting conditions. Planets forming around carbon-rich stars will naturally produce carbon-rich comets. Systems colder than ours will yield different ices. Variation is expected and anomalies are not proof of code. But skeptics also admit that if code existed, chemistry is where it would be found. It is durable, it is measurable, and it is nearly impossible to erase. Light fades, signals weaken, structures erode, but molecules persist. Chemistry is the most enduring way to write across the galaxy. The speculation deepens when we recall how much of our own search for life is chemical. Astronomers already scan exoplanet atmospheres for biosignatures: oxygen, methane, water, carbon dioxide, ratios that might suggest biology. We are already reading chemistry as code, looking for meaning in molecular distributions. The only question is whether we are prepared to consider that intelligence might use the same method deliberately. If we use chemistry to infer life, why would intelligence not use chemistry to announce it? The logic is simple, the method universal, the endurance unmatched. The only challenge is recognition. Would we notice if code were written into ice and dust? Or would we dismiss it as anomaly, as mere diversity of nature? Oumuamua did not stay long enough for such analysis. Its faintness, its speed, and its lack of visible outgassing left little chemistry to study. Borisov, by contrast, offered clear cometary activity, with chemical ratios much closer to what we know, reassuring in their familiarity. Atlas brought something different. Its chemistry was neither ordinary nor extreme enough to scream design, but unusual enough to provoke questions. And in those questions lies the unease. What if chemistry is not just geology? What if anomalies are not just diversity? What if, hidden in plain sight, chemistry itself is code? Even if no intelligence is involved, the metaphor of code remains powerful. Chemistry is information. Every ratio tells us something about temperature, pressure, elemental abundance, history. The molecules are records, written without intention but still readable. In this sense, interstellar visitors are archives. Each one carries data from another world, preserved in ice and dust. To decode them is to read the galaxy's history. To speculate about alien signatures is to extend that metaphor further, to wonder whether someone else has already written in this book, leaving behind intentional records for others to find. The difficulty, of course, is proving intention. Nature produces patterns. Stars produce anomalies. Chemistry is messy, and coincidences abound. To claim code requires extraordinary evidence, and so far none exists. Yet the absence of proof does not erase the plausibility. Chemistry as code is compelling because it is possible, not because it has been proven. And when possibility aligns with anomaly, imagination fills the gap. Atlas may be only unusual, but unusual is enough to remind us that chemistry could carry meaning if anyone chose to put it there. If we ever do encounter unmistakable code, what then? What if a future interstellar comet reveals isotopic ratios aligned with prime numbers, or molecules arranged in non-natural distributions, or elements present in abundances that defy formation models? The implications would be profound. It would not mean communication in real time, but communication across epochs. A message written billions of years ago, preserved in ice, delivered by chance, discovered by spectroscopy. The sender may be long gone, the civilization extinct, the intention forgotten, but the message would endure. The galaxy would speak to us through chemistry, and we would know we are not the first. For now, chemistry remains ambiguous. Science interprets it as geology. Speculation interprets it as potential code. The truth may be simpler. The truth may be that variation alone explains everything. But the very act of measuring, of cataloguing, of noticing, keeps the possibility alive. We cannot yet dismiss the idea that ice and dust may carry alien signatures, hidden in ratios we do not yet know how to read. We can only admit that if such code exists, comets are the most likely medium, and that every interstellar object we see is another chance to check, another chance to wonder, another chance to question what messages might be written in silence. The more of these visitors we detect, the more our catalogue of chemistry will grow. Patterns may emerge, and with them, conclusions. Perhaps variety will prove randomness. Perhaps anomalies will prove intention. Perhaps both will coexist. But until then, chemistry remains both data and code, both natural record and possible message. And each time ice vaporizes in sunlight, each time dust scatters through telescopes, we are reminded that meaning may not come through signals alone. It may come through molecules, through ratios, through signatures, etched in matter itself, drifting for billions of years, waiting for eyes to see and minds to decode. Every interstellar visitor that crosses our solar system is catalogued by its orbit. Astronomers calculate the shape, the velocity, the angle of approach, and the trajectory as it leaves again. These numbers are precise, rooted in physics, and they allow us to project where the object came from and where it is going. Yet behind that precision lies a problem. The galaxy is chaotic, filled with gravitational influences, and the history of a trajectory cannot be reconstructed with certainty. By the time we detect a visitor, its path has been bent and reshaped countless times, altered by encounters we cannot trace, by stars we cannot account for, by forces we cannot fully model. What looks like a clean hyperbolic orbit today is the end result of billions of years of motion, and what it conceals is everything that came before. This uncertainty is often dismissed as noise, as an unavoidable limitation of astronomy. But it also creates space for speculation. If we cannot reconstruct the full history of a trajectory, then we cannot entirely dismiss the possibility of intention. Randomness is expected, but randomness can also be an illusion. A path that looks arbitrary may not be. A trajectory that seems natural may conceal purpose. And the more interstellar visitors we detect, the more this tension grows. Each one arrives with the appearance of chance, but each one also forces the question, what if the chance is only apparent? Oumuamua was the first to highlight this tension. Its incoming trajectory suggested an origin near the constellation Lyra, roughly along the direction of the solar apex. That is, it appeared to come from the general direction in which our sun is moving through the galaxy. This could be coincidence, explained by probabilities and geometry, but it raised questions. Was it truly random, or was it aligned in a way that mattered? The uncertainty of its path made it impossible to know. All we could say was that it appeared to have arrived by chance, and that appearance may or may not be reality. Borisov was easier to explain. Its orbit looked random, its path consistent with the expected scattering of cometary bodies. No anomalies appeared, nothing to suggest anything but chance. Atlas fell somewhere in between. Its hyperbolic orbit, like the others, resisted precise backtracking. Its origin remained uncertain, its future equally so. Again, the illusion of randomness played its role. To science, this is sufficient. To speculation, it is a gap. And gaps invite possibility. The difficulty lies in distinguishing what is truly random from what only appears so. Human beings are skilled at recognizing patterns, sometimes too skilled. We see intention where there is none, design where there is only coincidence. Yet the inverse is also true. True intention can be disguised as randomness, and without evidence we cannot tell the difference. This is why trajectories matter. They are not just paths through space, they are signals in their own right, carrying information not only about where an object is going, but about what it might mean. One unsettling theory suggests that if reconnaissance is occurring, trajectories are the perfect disguise. A probe embedded in a comet would not move differently than a natural object. It would follow the same gravitational laws, the same hyperbolic curve. To observers, it would appear random, indistinguishable from debris. The illusion of randomness would conceal the truth of design. Only anomalies in acceleration or trajectory could betray it, and even then, natural explanations might suffice. Oumuamua's unexplained acceleration was precisely such a case. Outgassing was proposed as the cause, but no coma was detected. To some, this looked like hidden propulsion. To others, it was only natural physics in an unfamiliar form. The illusion of randomness held. Another perspective frames trajectories as opportunities. Even if natural, they can bring objects close to planets and stars in ways that look purposeful. An interstellar comet passing through our system can measure our atmosphere, absorb our emissions, or record our signals. None of this requires steering, none of it requires intention. But from the perspective of those being observed, it can feel like surveillance. The illusion is not only in the orbit, but in the encounter. What feels deliberate to us may be entirely natural, yet the effect is the same. We are measured, whether or not someone meant to measure us. The illusion deepens when we consider the sheer number of possible trajectories. Trillions of objects wander interstellar space, each with its own path. The probability that some will pass close to our sun is not zero, but inevitable. Yet inevitability does not erase unease. To see 3 in less than a decade feels like more than chance, even if statistics say otherwise. Randomness does not feel random when it arrives in clusters. It feels patterned, it feels meaningful, it feels like something concealed beneath the illusion. Science addresses this unease by refining models. Better surveys, larger data sets, more detections. With enough visitors, the randomness will become clear. Patterns will resolve into distributions, anomalies into expected variation. But speculation remains because even with more data, the illusion cannot be fully dispelled. No matter how many we detect, each individual trajectory will remain uncertain, its history irretrievable. The past cannot be reconstructed with precision, and so intention can never be entirely ruled out. The illusion of randomness is permanent, a feature not of objects themselves but of our limited perspective. This raises a deeper question. If intention were present, would we even know? Could a probe disguised as a comet leave any trace we could identify? Or would the illusion be so complete that we would never notice? The unsettling answer is that we may never be able to tell. To us, every trajectory would look random, every orbit natural, every passage chance. The only way to break the illusion would be direct interception, direct measurement, direct evidence. Until then, the question remains unresolved, and each visitor remains both natural and possibly not. Cultural narratives amplify this ambiguity. Humans are drawn to stories of hidden design, of secrets disguised as chance. The idea that interstellar objects could conceal intention resonates with myths of omens, signs, and visitations. What we see as debris may be interpreted as messages. What we see as randomness may be interpreted as alignment. The illusion becomes not just a scientific problem, but a psychological one. We interpret, we project, we imagine. And in doing so, we blur the line between chance and purpose. Even if all interstellar visitors are natural, the illusion of randomness still matters. It shapes how we think about the galaxy, how we interpret events, how we understand our place. Each trajectory is both data and mystery, both calculation and uncertainty. We can predict the path forward, but not the history behind. We can model the orbit, but not the origin. We can measure the curve, but not the meaning. In that gap, speculation thrives. The illusion remains, and with it, the possibility of concealment. As more objects arrive, the illusion will persist. Some will look ordinary, some anomalous, some both. Each one will carry the same uncertainty, the same ambiguity, the same potential to conceal. Whether debris or design, whether intention or chance, the trajectories will always appear random, and we will always be left to wonder what might lie beneath that appearance. The galaxy may be filled with wanderers, and among them perhaps more than wanderers. The illusion of randomness ensures that we cannot know, and that not knowing will always keep the question alive. When the first interstellar object was detected, speculation surged almost instantly. Was it natural or artificial? Could it be a probe, a messenger, a remnant of a civilization more advanced than ours? The debate faded as evidence leaned toward natural explanations, but the idea never really disappeared. Each new visitor brings it back, and behind that speculation lies a deeper question that goes far beyond comets and rocks. If there are other civilizations in the galaxy, why are they so quiet? Why do we see no clear signals, no unmistakable evidence, no announcements of their existence? One answer, unsettling in its implications, is that silence is not absence. Silence is strategy. Silence is safety. This is the essence of what is often called the dark forest problem. The metaphor comes from the image of a forest at night. Imagine a hunter moving through the trees. The forest is filled with other hunters, each one armed, each one cautious, each one uncertain of the intentions of others. In such an environment, to reveal yourself is to risk destruction. To call out, to announce your presence, is to invite danger. The safest choice is silence. You watch, you listen, you move carefully, but you do not reveal. Applied to the galaxy, the dark forest theory suggests that civilizations remain quiet, not because they do not exist, but because survival demands it. They may listen, they may observe, but they do not speak. They remain hidden, waiting, hoping not to be noticed by others who may not be friendly. This idea is speculative, but it explains the paradox of silence. Radio searches for extraterrestrial intelligence have scanned the skies for decades without unambiguous success. No clear signals, no obvious beacons. The absence of evidence has been interpreted as rarity, as the possibility that intelligence is uncommon or short-lived. But the dark forest perspective offers another explanation. Intelligence is common, but cautious. Civilizations survive only if they remain silent. The galaxy is not empty, but filled with listeners, each one hiding in the dark. The relevance to interstellar visitors becomes clear when we consider their silence. Oumuamua transmitted no signal. Borisov carried no beacon. Atlas displayed no artificial anomalies. To science, this proves natural origin. To speculation, it proves strategy. If these were probes, their silence would be deliberate. A probe broadcasting loudly would expose itself, would reveal its creators, would break the rule of survival in a dark forest. A probe disguised as a comet, moving silently, blending with natural debris, would fit perfectly within the strategy. It would observe without revealing, measure without announcing, hide within the background noise of the galaxy. Silence is not evidence of absence. Silence is safety. This perspective reframes what we expect from contact. For decades, the popular image has been one of signals, a powerful radio transmission, a laser beacon, a deliberate attempt to communicate across the stars. But the dark forest problem warns that such signals may never come. To transmit is to risk, and risk is survival's enemy. If we are waiting for signals, we may wait forever, not because others are absent, but because they are hiding. The galaxy may already be filled with civilizations, each one choosing silence, each one unwilling to risk exposure. The whispers we see in interstellar visitors may be the only traces we will ever encounter. The unsettling part of this theory is that it applies to us as well. Humanity has already broadcast signals into space, both intentionally and accidentally. Our radio leakage has been escaping for decades, announcing our presence to anyone within range. Some scientists worry that this is dangerous, that we are revealing ourselves in a galaxy where silence may be the rule. If the dark forest is real, then our transmissions are like a campfire in the night, drawing attention in a place where attention may be fatal. The safer strategy would be to listen only, to observe without revealing, to remain quiet like the hunters in the forest. But it may already be too late. Our signals are out there, and we cannot take them back. This raises another interpretation of interstellar visitors. If silence is the rule, then perhaps these objects are not only wanderers but watchers. A disguised probe hidden in a comet could fit the strategy perfectly. It would not announce itself, it would not risk communication, it would simply watch and record. It could measure our emissions, catalogue our chemistry, note our presence, and then continue on its way, delivering its data elsewhere without ever revealing its true purpose. In a dark forest, this would be the safest form of reconnaissance. Observation without exposure, silence as survival. Skeptics counter that this is unnecessary. Natural explanations suffice. Interstellar debris is expected, and the absence of signals is not surprising. Silence proves nothing but the limits of our detection. Yet the dark forest theory remains persuasive because it aligns with caution. It acknowledges the risks of exposure in a galaxy we do not yet understand, and it resonates with human intuition, because we know from our own history that encounters between civilizations are rarely safe, rarely balanced, rarely equal. Silence may not only be strategy, it may be wisdom. The theory also forces us to confront a difficult choice. Should we continue transmitting, or should we remain quiet? Should we attempt to announce ourselves, or should we assume that silence is safety? The debate is unresolved. Some argue that any advanced civilization would already know of us, that our emissions are too faint to matter, that communication is worth the risk. Others argue the opposite, that the dark forest is real, that silence is the only way to avoid danger, and that broadcasting is reckless. Interstellar visitors sharpen this debate, because each one is a reminder that we may not be alone, that we may already be observed, that silence may not protect us if we have already broken it. What the dark forest problem truly reveals is how little we know. We do not know if civilizations exist. We do not know if they are dangerous. We do not know if silence is strategy or coincidence. What we know is only this: the galaxy is vast, and the silence we observe is not proof of emptiness. It may be concealment. It may be survival. It may be the rule by which every intelligent species abides. And if that is true, then the interstellar visitors we see may be more than wanderers. They may be instruments of observation, perfectly consistent with a galaxy where silence is safety. This perspective does not mean that Oumuamua, Borisov, or Atlas were artificial. They were most likely natural. But the possibility that they were not cannot be dismissed entirely. And within that possibility lies the reminder that silence is not absence, that silence may be the most universal rule of survival. The dark forest theory lingers because it cannot be disproven. Every silent visitor is consistent with it. Every absence of signal is consistent with it. And until we know otherwise, we live within that uncertainty, never sure whether the silence we hear is emptiness or strategy. When we think of interstellar visitors, the first instinct is to see them as random debris, fragments of worlds long gone, chemistry frozen into place by cold and distance. They drift across the galaxy without aim, and occasionally one crosses our path whispering of another star's history. But as speculation builds, another idea begins to take shape. What if some of these objects are not only wanderers but survivors? What if they are remnants not just of stars and planets, but of civilizations that once flourished and are now gone? If so, they may carry with them lessons we are only beginning to imagine, and those lessons are linked to a concept that has troubled astronomers and philosophers alike for decades: the Great Filter. The Great Filter is a framework meant to explain a paradox. We know that the galaxy contains hundreds of billions of stars. We know that many of those stars host planets, and many of those planets may resemble Earth. We know that life arose here quickly, that intelligence emerged, that technology followed. By those measures, the galaxy should be filled with civilizations. We should see evidence everywhere. Signals, probes, structures, something undeniable. And yet, we see nothing. The silence persists. The Great Filter asks a simple but unsettling question. If life is common, what prevents it from becoming widespread, visible and enduring? Somewhere along the path from simple chemistry to galactic civilization, there must be barriers, filters that most cannot cross. Those barriers could exist behind us. Perhaps life itself is rare. Perhaps intelligence almost never arises. Perhaps civilizations usually collapse before they become technological. If so, then humanity is extraordinarily lucky, one of the few to have made it this far. But the alternative is darker. Perhaps the Great Filter lies ahead of us. Perhaps civilizations like ours emerge often, but something prevents them from lasting. War, resource collapse, climate, uncontrolled technology, cosmic catastrophes. Whatever the cause, most civilizations may not survive long enough to leave a permanent mark. In this scenario, the silence of the galaxy is not comforting but ominous. We do not hear others because most are gone, and we may join them. Interstellar objects fit uneasily into this picture. On the one hand, they are natural, geological, the inevitable debris of star systems. On the other hand, they may also be tombstones. If a civilization once existed in another system, fragments of its world may have been scattered into interstellar space. Over billions of years, those fragments could drift across the galaxy, carrying with them chemical records, technological ruins, or subtle anomalies. To encounter one would not be contact in the living sense. It would be archaeology on a cosmic scale. We would not be speaking to contemporaries but to ghosts. Interstellar comets and asteroids may not only tell us about how planets form, but how civilizations die. This perspective ties the idea of the Great Filter to what some call galactic graveyards. If civilizations once flourished, their absence today implies they did not endure. The galaxy may be littered with the remains of their existence, scattered in debris fields, hidden in asteroid belts, drifting in interstellar dark. We may never notice most of it, because time erases signatures. Structures collapse, metals corrode, signals fade. Only the most durable fragments persist, perhaps indistinguishable from natural bodies. A probe billions of years old might be eroded to stone, its machinery gone, its purpose unreadable. A world destroyed might scatter fragments indistinguishable from comets. The graveyards are invisible, but their shadows linger in the silence. For humanity, the idea of the Great Filter casts every interstellar visitor in a new light. When we see Oumuamua, Borisov or Atlas, we cannot help but wonder whether they are simply debris, or whether they are remnants of histories we will never know. The unsettling part is that we cannot distinguish between the two. Natural debris and ancient ruins may look the same after billions of years. To us, the difference may be forever concealed. The shadows of the great filter may already surround us, and we may not recognize them when we see them. The lesson here is sobering. If the galaxy is filled with graveyards, then our survival is not guaranteed. We may be rare in having reached this point, but rarity does not ensure endurance. The silence of the galaxy could be warning, not reassurance. Every interstellar object that passes could be interpreted as a fragment of that warning, a reminder that civilizations rise and fall, and that we are not exempt from the forces that end them. The Great Filter may be universal, a pattern that no intelligence escapes, a shadow cast across every world that tries to climb beyond its cradle. Some thinkers argue that evidence of the filter ahead of us would be the most frightening discovery imaginable. If we found undeniable proof of a dead civilization, a probe eroded beyond function, a fragment with engineered isotopes, a chemical pattern too precise to be natural, it would confirm that intelligence exists elsewhere. But it would also confirm that intelligence does not endure. If they did not survive, why should we? If they could not overcome the challenges of longevity, why assume we can? To find evidence of others would be to find evidence of our likely fate. Silence may be unsettling, but it may also be merciful. Others argue the opposite. To find ruins would be hope, not despair. It would prove that we are not alone, that life has arisen more than once, that intelligence has walked other worlds. The Great Filter would then likely be behind us, not ahead. The rare step would be the emergence of intelligence itself, not its endurance. In that case, our future could still be open. The shadows of galactic graveyards would still haunt us, but they would not guarantee our doom. They would be evidence that life can reach our level, and that perhaps we are among the few who will carry it further. Interstellar objects sharpen this debate because they are tangible. They are not distant planets we cannot reach. They are visitors here, now, passing through our skies, leaving data we can measure. To see them as natural is enough, but to see them as potential fragments of civilizations changes everything. Each one becomes a possible lesson, a possible clue to where the Great Filter lies. Their silence may not only be a whisper of geology, but a silence inherited from civilizations that no longer exist. The shadows of the Great Filter extend into culture as well. Humanity has always built graveyards, monuments, ruins. We preserve memory in stone, in books, in data. Yet even our most durable records may not survive the passage of millions of years. If we vanish, our ruins will erode, our signals will fade, our traces will blend with natural geology. To any future observer, we may look no different than the interstellar debris we now study. We too may become whispers of silence, fragments mistaken for chance, anomalies dismissed as natural. The shadows we see may one day be the shadows we cast. In the end, the lessons of galactic graveyards are ambiguous. They remind us that silence is not simple, that absence may conceal presence, that what looks like debris may hide history. They remind us that survival is not guaranteed, that the challenges we face may be universal, that the filter may yet lie ahead. And they remind us that every interstellar visitor carries with it not only chemistry, but possibility. The possibility that it is a fragment of something more, a piece of a history erased but not forgotten. The shadows of the Great Filter stretch long, and we walk within them whether we recognize it or not. When Atlas was first detected, it didn't look like the kind of object destined to reshape how we think about the galaxy. It was faint, it was distant, and it was one more dot among the countless detections catalogued nightly by sky surveys. Yet the more closely astronomers studied it, the more it stood apart. Its orbit marked it as interstellar, only the third of its kind ever confirmed. Its chemistry, dominated by carbon dioxide in unusual proportions, made it unlike the comets we know from our own system. It was neither wholly familiar like Borisov, nor wholly strange like Oumuamua. It was something in between, straddling the line between expectation and anomaly. And it arrived not in isolation, but as the third in a sequence following two predecessors that had already unsettled our confidence. This timing alone raises the question, could Atlas be the harbinger of what comes next? The word harbinger carries weight. It does not mean conclusion, it means sign, forerunner, messenger of something yet to arrive. To call Atlas a harbinger is not to claim that it is extraordinary in itself, but that it signals a turning point, a shift in awareness, a transition from speculation to inevitability. If Oumuamua was the revelation and Borisov the confirmation, then Atlas may be the warning. Not because it is artificial, not because it carries messages, but because it suggests that this is only the beginning. What was once rare is now routine. What was once anomaly is now pattern. What was once chance is now certainty. The harbinger question rests partly on probability. Before Oumuamua, interstellar visitors were theoretical, their existence predicted but never observed. The expectation was that they would be rare, perhaps one passing every century, too faint to notice, too fast to catch. The discovery of one seemed extraordinary. The discovery of a second within 2 years was startling. The discovery of a third less than a decade later shifts the entire framework. The universe has not changed, but our ability to see it has, and with that ability comes recognition that these objects may be far more common than we thought. Atlas is not remarkable only for what it is, but for what it represents, the opening of a floodgate. If we have seen 3 already, how many more will follow? To treat Atlas as a harbinger is to acknowledge that the flow of interstellar visitors is not a trickle, but a current. We are no longer at the beginning of a story that ends with a single object. We are at the beginning of a story that will expand, with new arrivals every few years, perhaps every year, perhaps more. Each one will be measured, catalogued, debated. Some will look ordinary, some will look strange, some will defy explanation altogether. The pattern will grow, and with it, the unease. For Atlas to be a harbinger means that we are entering a new era, one in which interstellar visitors are expected, and with expectation comes pressure to interpret what they mean. Interpretation splits into 2 paths. For science, Atlas is a harbinger of discovery. Each new interstellar object provides chemical data from another star system. Each one is a free sample return mission, a way of studying environments beyond our reach. Over decades, a catalogue of such objects will reveal the diversity of planetary formation across the galaxy. Atlas, with its unusual chemistry, is a preview of the variety we will see. Some systems will be water-rich, others carbon-rich, others dominated by exotic ices. The galaxy will reveal itself piece by piece, comet by comet, and the harbinger is that we are only at the beginning of this survey. For science, the message is clear. Prepare for abundance, not rarity. For speculation, the harbinger carries darker implications. Each new visitor is another opportunity for hidden design, another chance that what looks like debris is something more. The more often they come, the more often the question will arise. If even one is artificial, then the galaxy is not silent. If even one is a probe, then we are not alone. Atlas does not prove this, but its presence as the third in a sequence makes the speculation harder to ignore. Silence repeated becomes louder, and the harbinger may be that silence itself is message. Not absence, but concealment. Not random, but deliberate. The possibility that one of these objects carries more than chemistry is no longer a curiosity, but an inevitability. We will continue to ask with each detection. The harbinger question also ties into time. Oumuamua passed too quickly for close study. Borisov was observed but never intercepted. Atlas too will vanish before any mission can reach it. 3 opportunities, 3 losses. If these objects are common, the harbinger may be that we must change how we respond. We cannot remain passive watching them pass. If we want answers, we must be ready to intercept, to sample, to meet them in space before they vanish. Atlas reminds us that time is limited. Visitors arrive and depart quickly. If the sequence continues, the harbinger is not only of abundance but of urgency. The window for action is short, and if we wait, the answers will slip away again. There is another sense in which Atlas may be the harbinger, one more unsettling. Each interstellar visitor so far has been harmless, passing at safe distances, offering only light and data. But there is no guarantee this will always be the case. If such objects are common, then the probability increases that one will arrive on a trajectory intersecting Earth. A comet from another star system, moving at interstellar speeds, would be nearly impossible to deflect with our current technology. Its impact would be catastrophic. Atlas reminds us that visitors exist, and if they exist, so does the possibility of danger. The harbinger may not be of science or speculation, but of risk. A reminder that the cosmos does not only offer knowledge, but threats. Even if none of these darker scenarios unfold, the psychological weight of a harbinger remains. Humanity has always looked for signs, for omens, for markers of what comes next. Atlas arrives at a moment when our awareness of the cosmos is expanding rapidly. We are beginning to map exoplanets, to study atmospheres, to search for biosignatures. We are building instruments sensitive enough to catch faint wanderers from across the galaxy. Against this backdrop, Atlas feels like more than coincidence. It feels like timing, like message, like signal that we have entered a new phase. Rationally, it may be nothing more than improved detection. Emotionally, culturally, it feels like the universe has begun to answer questions we were only just ready to ask. To call Atlas a harbinger is not to claim certainty. It is to acknowledge possibility. It may be only debris, only chemistry, only a natural object among countless others. But its arrival in sequence, its anomalies in composition, its presence at this moment in our history, all of it combines to create the impression of transition, from rarity to routine, from chance to pattern, from isolation to connection. Atlas may be only one visitor among many, but it signals that many more are coming, and with them, questions we cannot yet answer. The harbinger role does not end with Atlas. The next visitor may confirm its meaning, or challenge it, or redefine it, but the impression lingers. Oumuamua was the revelation, Borisov was the reassurance. Atlas is the warning. Not a warning of doom, but of change. A warning that the galaxy is not static, that our system is not closed, that visitors will continue to arrive. The harbinger is not about what Atlas is, but about what follows, and what follows is inevitable. When Oumuamua was discovered in 2017, the astronomical community treated it as a once-in-a-lifetime event. The first interstellar object ever confirmed, its detection seemed miraculous, a stroke of luck that might not be repeated for centuries. The odds of catching such a faint traveller so small and moving so quickly were thought to be minuscule. The working assumption was that interstellar visitors passed through our solar system rarely, and that if they did, we would almost never see them. Yet within 2 years, Borisov appeared, and only a short time after that, Atlas. In less than a decade, 3 objects from beyond our solar system have been confirmed. What was supposed to be rare has revealed itself to be common, and the conclusion is unavoidable. If one comes, many will follow. This shift in perspective is not merely about numbers, it is about inevitability. Once we know that interstellar debris exists, and that our instruments are capable of detecting it, the floodgate opens. We cannot retreat to the old assumption of rarity. The galaxy is filled with debris ejected from other star systems. Our solar system is not isolated, not protected, not exceptional. It is embedded within a network of wandering bodies that cross its boundaries routinely. To detect one is to acknowledge many, and to acknowledge many is to prepare for the idea that such encounters will be a permanent part of our future. The reasoning behind this conclusion is straightforward. Planetary formation is a violent process. Young stars surrounded by disks of gas and dust produce not only planets, but countless leftover fragments. Many of these fragments are gravitationally destabilized and ejected into interstellar space. Given hundreds of billions of stars, the number of ejected fragments is astronomical, enough to populate the galaxy with a vast background population of wanderers. Our solar system moves through this background as it orbits the galactic center, and so encounters are inevitable. What was once invisible to us is now visible because our technology has advanced to the point of recognition. The conclusion is not that visitors have suddenly become common. It is that they were always common, and only now do we notice. If one comes, many will follow, and each one will be different. Oumuamua was enigmatic, with its unusual shape and unexplained acceleration. Borisov was familiar, looking much like a comet from our own system, complete with coma and tail. Atlas was a hybrid, chemically unusual but still recognizable as a comet. This diversity is telling. It means that interstellar visitors do not conform to a single type. They are a spectrum reflecting the variety of planetary systems across the galaxy. Some will resemble what we know, some will surprise us, some may defy explanation entirely. The sequence so far is only a sample, a hint of the diversity to come. For science, this is a treasure. Each new visitor offers data from another star system, information we could never obtain otherwise. Their chemistry tells us about the conditions in which they formed. Their activity reveals how ices behave under different circumstances. Their orbits provide clues about how material is ejected and distributed across the galaxy. Over time, the accumulation of visitors will build a catalogue, a map of planetary diversity written in ice and dust. The promise is immense, but the challenge is that most visitors pass too quickly for close study. We see them faintly from a distance, and then they are gone. If one comes, many will follow, and the task will be to meet them, to intercept them, to study them directly before they vanish. For speculation, the inevitability carries different weight. If many will follow, then each new arrival is another chance that one may not be what it seems. If probes are disguised as comets, if reconnaissance is embedded within debris, if intention hides within silence, then the repetition increases the likelihood that one of these objects will reveal something more. Silence alone becomes less persuasive when it is repeated again and again. The possibility that one is different lingers, and as the number of visitors grows, the expectation that anomalies will accumulate grows as well. If one comes, many will follow, and among the many one may finally break the pattern of silence. The inevitability also carries risk. So far, the 3 confirmed visitors have been harmless, passing through at safe distances. But the laws of probability suggest that eventually, one may come close enough to pose a danger. A fragment moving at interstellar velocity on a collision course with Earth would be nearly impossible to deflect with our current capabilities. Local comets already pose threats. Interstellar comets would be faster and harder to predict. If visitors are common, then the risk is real. If one comes, many will follow, and one of those many may one day cross our path in a way that is not harmless. Atlas and its predecessors remind us that the cosmos delivers both knowledge and peril. The repetition also affects how we think about contact. If civilizations exist elsewhere, they too would see the abundance of interstellar debris. They too would recognize the opportunity to use it as camouflage, as courier, as probe. The more common the objects, the easier it becomes to hide within them. If one comes, many will follow, and within the many a few could be engineered. We may never know the difference, but the possibility persists, and repetition makes it harder to ignore. Silence cannot erase the suspicion. Each arrival renews it. Psychologically, the shift is profound. Humanity has long imagined the cosmos as distant, separate, requiring immense effort to reach. But the arrival of interstellar visitors collapses that distance. Pieces of other stars come to us. They cross our sky. They leave traces in our data. They remind us that the galaxy is not out there, but here. If one comes, many will follow, and with them comes the realization that we are already part of a galactic exchange, not in communication, not in travel, but in matter itself. The galaxy is not static. It flows, it exchanges, it delivers. We are recipients whether we choose to be or not. The lesson of inevitability also forces us to reconsider preparation. 3 visitors have already escaped without interception. Each one was a lost opportunity to sample alien material directly. If many will follow, then the next step is to prepare missions ready to launch quickly, capable of reaching these objects before they vanish. The window is short, the trajectory is steep, the challenge is immense. But the opportunity is unique. No other method can bring us material from beyond our solar system so directly. If one comes, many will follow, and with them comes a responsibility to meet them, to seize the chance before it is gone. In cultural terms, inevitability has always shaped our stories. We tell ourselves that 1 event is exception, 2 a coincidence, 3 a pattern. With 3 interstellar visitors already observed, the pattern is set. The expectation has shifted. The next arrival will not be surprise but confirmation, and with each confirmation, the sense of inevitability deepens. The harbinger is not only Atlas, the harbinger is the sequence itself. Oumuamua opened the story, Borisov continued it, Atlas reinforced it. The next visitor will make it undeniable. If one comes, many will follow, and the story will not stop. For now, we wait. The surveys continue. The telescopes scan. The data accumulates. Somewhere in the darkness, another visitor is already on its way. It may be months away, years away, decades away, but it is coming. Its orbit is already set, its arrival inevitable. The question is not whether, but when. And when it comes, it will remind us again of the rule we have now learned. If one comes, many will follow. The galaxy is not empty. It is moving, drifting, delivering. The visitors will continue, and with them, the questions we cannot yet answer. When Oumuamua streaked through the solar system in 2017, observatories around the world scrambled to measure it. The discovery came late, the object already outbound, moving too quickly for close inspection. By the time telescopes were turned toward it, the window for study was short. What data was gathered was tantalizing but incomplete. Its light curve suggested a bizarre shape, its trajectory showed unexplained acceleration, and yet its faintness left too many uncertainties unresolved. The world's instruments had caught a glimpse of something extraordinary, but were not fully prepared for the opportunity. The frustration was palpable, and it set the stage for what followed. 2 years later, when Borisov appeared, observatories were ready. Telescopes from professional facilities to amateur setups turned toward it, tracking its motion and recording its activity. This time, the data was rich, detailed, and reassuring. Borisov looked like a comet, behaving much as one would expect, offering chemistry that could be catalogued and compared. Yet even in its familiarity, tension lingered. Was it truly ordinary, or did its presence so soon after Oumuamua suggest that something larger was unfolding? Scientists reported calmly, but speculation pressed in from the edges, and observatories once again found themselves balancing caution with wonder. Then came Atlas. Detected by the Asteroid Terrestrial Impact Last Alert System, it joined the growing list of interstellar visitors. Its unusual chemistry set it apart from the comets of our own solar system. Its orbit confirmed its foreign origin, and once again telescopes pivoted to record it before it vanished. 3 objects in less than a decade forced a reckoning. This was no longer an anomaly, no longer a curiosity. Interstellar visitors were not rare but detectable, perhaps even common, and observatories found themselves caught between 2 impulses, to measure with precision and to speculate on meaning. Science thrives on restraint. Observatories are built to collect data, not to confirm suspicions. Their role is to track, to measure, to quantify. For Oumuamua, they produced orbital solutions and light curves. For Borisov, they catalogued gases and dust. For Atlas, they reported chemical ratios and activity. Each object was described in terms of what could be measured, nothing more. But speculation never stays outside for long. When data is incomplete, imagination fills the gaps. Observatories cannot help but feel the weight of possibility pressing against their caution. Could these visitors be probes? Could their anomalies be intentional? Could their silence itself be message? Science resists those questions, but it cannot silence them completely. The strange shows in the language of reports. Technical papers describe the facts, but behind them linger the unsaid. Terms like unusual, unexpected, unexplained appear often, each a quiet acknowledgement that not everything fits cleanly. In Oumuamua's case, the unexplained acceleration was reported with careful neutrality, yet it immediately fueled speculation outside the community. Some researchers cautiously entertained exotic explanations, while others pushed back firmly. The debate spilled beyond academia, feeding media headlines and public fascination. Observatories watched as their cautious data became fodder for speculation they could not control. This tension has only grown with each visitor. Borisov was less controversial, but its timing, so soon after Oumuamua, kept speculation alive. Atlas reignited questions, its chemistry distinctive enough to feel like a whisper of something more. Each time, observatories documented what they could, and each time speculation bloomed around their findings. The two exist in uneasy balance. Science cannot embrace speculation without evidence, but speculation cannot be silenced when anomalies are reported. Observatories are on edge, caught between the duty to remain cautious and the inevitability of human imagination. The edge is not only cultural but practical. Observatories must prioritize what they study, and interstellar objects pose a dilemma. They appear suddenly, move quickly, and vanish forever. To devote resources to them means diverting attention from other priorities: exoplanets, cosmology, solar system dynamics. Yet the chance to study matter from another star system is irresistible. Each detection forces decisions. How much telescope time should be spent? Which instruments should be used? What can be sacrificed to capture fleeting data before the object is gone? These choices carry weight, and the urgency leaves little room for hesitation. The limitations add to the frustration. Even the most powerful telescopes can only do so much from Earth. Spectra can reveal chemistry, but only roughly. Light curves can suggest shape, but not resolve it. Trajectories can be calculated, but not retraced with certainty. To go beyond requires spacecraft, and spacecraft require years of planning. Oumuamua was already gone before a mission could even be imagined. Borisov moved too quickly for interception. Atlas will escape as well. Observatories can measure, but they cannot chase. They record, but they cannot capture. This limitation gnaws at the scientific community, leaving them with tantalizing hints but no closure. And into that gap steps speculation. Each anomaly becomes magnified. Each uncertainty becomes a canvas. Observatories release cautious results, and outside voices amplify the mysteries. The public hears less about uncertainties and more about possibilities. Was Oumuamua a probe? Was Borisov truly ordinary? Was Atlas an omen? Observatories are left in the uncomfortable position of being both the gatekeepers of evidence and the unwilling catalysts of speculation. They cannot prevent imagination from running ahead of data, nor can they fully dismiss the questions that arise. This is not entirely new. Astronomy has long lived at the intersection of the measurement and imagination. Pulsars were once dubbed LGM for little green men, before their true nature was understood. Quasars were once mysterious enough to provoke speculation about alien civilizations. Time and data resolved those mysteries, but the process revealed the dynamic. Observatories provide facts, speculation interprets them, and sometimes speculation races ahead. The difference now is that interstellar visitors carry the possibility of intention in a way that pulsars and quasars did not. They move among us, they pass near our planet, they resemble messengers in form and timing. The temptation to speculate is stronger, and the restraint of science more strained. As more interstellar objects are detected, this strain will increase. Each one will generate data, each one will generate anomalies, each one will generate speculation. Observatories will remain on edge, wrestling with how much to acknowledge, how much to entertain, how much to ignore. The balance will be difficult. Too much caution risks appearing dismissive. Too much openness risks eroding credibility. The line between science and speculation will remain thin, and each new visitor will force the question anew. For humanity, this tension is both frustrating and fascinating. We crave certainty, but the cosmos rarely provides it. We want clear answers, natural or artificial, debris or probe, silence or message. But the data rarely allows such clarity. Observatories can only measure, and measurement alone cannot erase possibility. The result is a perpetual state of ambiguity, where science and speculation coexist, each feeding the other, neither able to fully resolve the mystery. Observatories stand at the centre of this dynamic, doing their best to stay grounded, even as the world looks to them for answers that may not yet exist. Atlas embodies this tension perfectly. Its chemistry is distinctive but not impossible. Its orbit is interstellar but not unique. Its silence is expected but still haunting. Science catalogues it as natural, but speculation cannot let go of what might be concealed. Observatories report their findings, but the questions spill beyond their walls. Could Atlas be ordinary? Almost certainly. Could Atlas be more? The possibility remains, and observatories cannot disprove it. This is the edge on which they live, the line they must walk, the balance they must maintain. The next visitor will only sharpen the strain. If it resembles Oumuamua, speculation will surge. If it resembles Borisov, science will emphasize normality. If it resembles Atlas, the ambiguity will deepen. Whatever it brings, observatories will again measure carefully, report cautiously, and wrestle with the speculation that follows. This will not end. If one comes, many will follow, and with each one the edge will grow sharper. Science will continue to wrestle with speculation, and speculation will continue to push against science. The tension is not weakness, but inevitability, born of our nature as seekers of both data and meaning. In the long run, only direct missions may resolve the tension. Until we can intercept an interstellar visitor, sample its material, and analyze it without ambiguity, observatories will remain on edge, measuring without closure, reporting without certainty. Until then, each visitor will remind us of the balance between what we know and what we imagine, between data and possibility, between science and speculation. And until then, the struggle will continue, as inevitable as the visitors themselves. Each interstellar visitor that crosses our path brings with it not only data about another star system, but also questions about ourselves. Oumuamua, Borisov and Atlas are not just physical objects. They are mirrors held up against humanity, forcing us to examine what we expect, what we fear, and what we are willing to believe. They arrive without words, without signals, without explanations, and yet their silence provokes introspection. In studying them, we do not only learn about the cosmos, we learn about our own assumptions, our own limitations, and the way we confront the unknown. When Oumuamua was first identified, it was described in the language of astronomy: orbit, light curve, brightness variations. Yet almost immediately another layer was added. Could it be artificial? Could it be a probe? Could it be evidence that we are not alone? The question was less about Oumuamua itself than about us. Why was the possibility of artificial origin so compelling? even with little evidence? Why did the anomalies trigger speculation that outpaced the data? The answer lies in our own psychology. We are a species that looks outward with expectation, that carries the hope and fear of contact. Oumuamua forced us to admit that we are ready to ask whether we are alone, even when the evidence is inconclusive. Borisov tested us differently. Its comet-like behaviour reassured scientists, its chemistry aligned with natural explanations, its activity looked familiar, and yet, because it followed so soon after Oumuamua, it forced us to ask whether we truly understand probability. Were two interstellar visitors in quick succession evidence of abundance or evidence of something else? Was it coincidence or pattern? Borisov was natural, but it held up another mirror, reflecting our tendency to question chance. We saw in it not only a comet, but a reminder that we struggle with randomness. When patterns appear, we instinctively search for meaning, even when meaning may not exist. Atlas brought yet another reflection. Its unusual chemistry made it neither wholly ordinary nor wholly strange. It sat in the space between reassurance and anomaly, forcing us to confront ambiguity. Was its high ratio of carbon dioxide to water simply the product of an unusual environment, or was it a signature of something more? Atlas reminded us that not all answers are clear, that sometimes data only deepens uncertainty. The mirror it held up showed us our discomfort with ambiguity. We prefer certainty, natural or artificial, harmless or dangerous, clear categories that give us resolution. Atlas denied us that clarity, and in doing so revealed our impatience with mystery. These visitors also force us to ask deeper questions about our place in the galaxy. Each one is a reminder that we are not isolated. Debris from other stars passes through our home, carrying chemistry from distant systems. We are part of a larger flow, part of a galaxy that exchanges material across vast distances. The question becomes, what does this mean for us? Are we passive recipients, simply watching as fragments drift by? Or are we participants in something larger, a network of exchange that we barely recognize? The visitors remind us that isolation is an illusion. The galaxy is interconnected, and whether or not life elsewhere exists, we are already linked through matter itself. Another question arises about survival. If interstellar debris is common, then so is risk. A comet from another system, on a collision course with Earth, would be catastrophic. Unlike local comets, which we can track and predict, an interstellar comet would arrive at greater speed, with less warning and with far more destructive potential. Each visitor we see is harmless, but each one reminds us of the possibility of danger. The mirror they hold shows us our vulnerability, our lack of preparation, our limited ability to defend ourselves against cosmic threats. They force us to ask whether we are ready for such an encounter, and the answer, at least for now, is no. Beyond survival, the visitors force us to confront the question of communication. If civilizations exist elsewhere, how would we know? Would we recognize a message if it were written in chemistry, in isotopes, in ratios of gases? Would we dismiss it as anomaly, as coincidence, as unexplained variation? The visitors remind us that recognition is not guaranteed. They force us to ask whether we are prepared to notice, whether our methods of interpretation are sufficient, whether we are open to possibilities that challenge our assumptions. The mirror shows us our biases, our tendency to expect certain kinds of messages and to overlook others. It forces us to admit that we may not yet know how to listen. The question extends further, to silence itself. The visitors are silent, offering no signals, no signs of intention. Does this silence mean they are natural, or does it mean something else? The dark forest problem lingers in the background, reminding us that silence can be strategy. The visitors force us to ask whether we are interpreting silence correctly. Do we assume too quickly that absence of evidence is evidence of absence? Or do we risk too much by imagining intention where none exists? The mirror shows us our struggle with uncertainty, our discomfort with silence, our need to fill it with meaning even when none may be there. Perhaps the most unsettling question the visitors force upon us is about our own future. If interstellar debris carries fragments of other systems, could it also carry remnants of civilizations that failed? If so, what does that say about our own chances of survival? Are we destined to leave behind only fragments, only debris, only silence? The mirror here is dark, reflecting our fear of impermanence, our awareness that survival is not guaranteed, our suspicion that we may not endure. Each visitor may be natural, but each one reminds us of the possibility of galactic graveyards and of our potential place among them. Yet the mirror is not only dark, it also reflects possibility. If interstellar visitors are common, then the galaxy is more accessible than we once believed. Material from other stars comes to us. With preparation, we could intercept it, study it, even bring it back. These objects may be the first step toward understanding the galaxy directly, not through distant observation but through tangible samples. They force us to ask whether we are ready to embrace this opportunity, whether we will invest the effort to meet them, whether we will act on the chance they present. The mirror shows us not only our fear, but our potential, our ability to learn, our capacity to reach outward. Humanity has always used the cosmos as a mirror. The stars have shaped our myths, our calendars, our navigation, our sense of place. Interstellar visitors extend this tradition into new territory. They are not distant points of light, but physical messengers crossing our system. They reflect not only who we are, but what we may become. The questions they force us to ask are not only scientific, but existential. Are we alone? Are we prepared? Are we fragile? Are we capable of recognizing what we see? The answers are not yet clear, but the questions themselves define us. In the end, the visitors are not only fragments of other systems, they are fragments of ourselves, mirrors in motion, reminders that the search for meaning in the cosmos is inseparable from the search for meaning within. Oumuamua, Borisov, Atlas. They do not speak, but they force us to ask, and in asking, we reveal who we are. The mirror they hold is silent, but in its silence we hear our own voices, our own fears, our own hopes, our own reflection, own. 3 interstellar visitors have come and gone. Oumuamua slipped past almost before we noticed. Borisov arrived with the familiar look of a comet, and Atlas followed with chemical anomalies that made it stand out from what we know. Each of them passed without harm. Each of them was treated as an opportunity for science, a source of fascination, and a spark for speculation. But all 3 were also reminders of something we cannot ignore. Interstellar objects are not under our control. They arrive unannounced, they follow trajectories we cannot alter, and they pass through our system at tremendous speeds. So far, the story has been harmless. The 4th may not be. The question is not whether another visitor will come. That much is inevitable. Surveys are improving, telescopes are scanning more of the sky than ever before, and interstellar debris is abundant. What we must ask is what happens when one arrives on a trajectory that intersects Earth. A comet from another star system moving at interstellar velocity would be a threat unlike anything in our recorded history. Local asteroids and comets already pose dangers, but their velocities are lower, their orbits easier to track, their deflection more feasible in theory. An interstellar object would be different, faster, harder to predict, and perhaps impossible to stop with the methods we currently imagine. Preparing for the 4th visitor is not only about science, it is about survival. The physics of the problem make it stark. A comet moving at 30 to 70 kilometers per second relative to Earth would deliver energy on impact far beyond anything we have experienced. Even a small body, a few hundred meters across, would release energy equivalent to many thousands of nuclear weapons. A larger one would be catastrophic on a global scale. Local impacts are rare but part of Earth's history. Interstellar impacts would be rarer still, but their potential consequences demand consideration. The probability may be low, but low probability events are inevitable on long enough timelines. If interstellar visitors are common, then eventually one will approach not at a safe distance, but on a path we cannot ignore. What makes the problem more difficult is detection time. Local asteroids can often be tracked years in advance. Their orbit's predictable enough to allow planning. An interstellar object, approaching at higher velocity from deep space, might be noticed only weeks or months before closest approach. The window for action would be short, the options limited, the consequences of inaction immense. Preparing for the fourth visitor means preparing for scenarios in which there is little time, little certainty, and little margin for error. It means building systems that can act quickly, not just observe passively. So far, our response has been reactive. Oumuamua was detected after it had already passed. Borisov was tracked while inbound, but still far too late for any mission to be launched. Atlas was confirmed, studied, and catalogued, but again without the possibility of interception. Each time we have watched visitors pass beyond reach. If the next one is harmless, the pattern will repeat. If the next one is not, we will face the consequences of unpreparedness. Preparing for the fourth means breaking that cycle. It means designing missions ready to launch on short notice, capable of intercepting visitors while they are still inbound. It means moving from observation to readiness. There are already proposals. Concepts like the Comet Interceptor mission, designed to wait in space and rendezvous with the yet-to-be-discovered comet, are steps in this direction. Expanding such ideas to target interstellar objects is a natural progression. Missions placed in standby orbit, equipped with the ability to accelerate toward an unexpected target, could finally allow us to meet a visitor directly. Preparing for the fourth means investing in these technologies now, before the opportunity, or the threat, arrives. It means acknowledging that interstellar objects are not rare curiosities, but ongoing realities, and that we cannot remain passive. The question of risk is not limited to impacts. Even without collision, interstellar visitors can alter our sense of safety. Each one reminds us of our vulnerability, our limited reach, our dependence on chance. Preparing for the fourth means preparing psychologically as well as technologically. How will humanity respond if a visitor looks different, larger, darker, more unusual than the last three? How will we interpret anomalies that do not fit cleanly within natural expectations? Will speculation overwhelm science? Will fear overwhelm reason? Each visitor is a test, not only of our instruments, but of our ability to remain measured, cautious, and prepared in the face of uncertainty. The possibility of artificiality lingers here as well. If one of these objects turned out not to be debris but design, how would we respond? Would we recognize it in time? Would we treat it as threat or opportunity? Preparing for the fourth means confronting that question, even if only as thought experiment. Silence so far does not erase possibility. The next visitor may look ordinary, or it may not. Our readiness must extend to both scenarios, natural danger and potential contact. Neither can be dismissed. Both demand preparation. The reality is that preparation has always lagged behind awareness. Humanity tends to act only after crises, building defences after disasters, investing only once losses are undeniable. Interstellar visitors do not offer that luxury. They come once, they pass once, and the chance is gone. If the next one is harmless, we will lose another opportunity. If the next one is not, the consequences will be irreversible. Preparing for the fourth means acting before certainty, before urgency, before disaster. It means learning from the first three that waiting is not enough. There is also a cultural dimension. Visitors from beyond the solar system capture imagination in a way that local asteroids do not. They arrive with mystery, with the possibility of message, with the suggestion of other worlds. They command attention not only from scientists but from the public. This attention can be leveraged. Preparing for the fourth is not only about technology but about communication. Explaining the risks, explaining the opportunities, explaining the need for readiness will determine whether humanity chooses to invest. The mirror these visitors hold up shows not only our vulnerability but our capacity to anticipate. Whether we act on that reflection is the real test. In truth, the fourth visitor is already on its way. Somewhere in the darkness, a fragment of another system is moving toward us, its orbit fixed by billions of years of motion, its arrival inevitable. We do not yet know when it will appear, or what form it will take, or what questions it will raise. What we know is only that it will come. When it does, it may pass quietly, another harmless wanderer, another opportunity missed. Or it may force us to confront risks and uncertainties more directly than ever before. Preparing for the fourth is not speculation, it is inevitability. The only uncertainty is whether we will be ready when it arrives. The first 3 interstellar visitors caught us by surprise, but by now, surprise is no longer the right response. Oumuamua opened the story, Borisov continued it, Atlas reinforced it, and the fourth is certain to come. Each one leaves behind not just data, but the awareness that we are part of something larger, something ongoing, something that will not end with a single event. Whether they are natural fragments, silent couriers, or something more, the sequence itself is message enough. We are no longer looking at isolated anomalies. We are witnessing the start of a pattern, and patterns demand interpretation. The question is whether we are at the beginning of something bigger than we realise, and whether that beginning is defined by arrival or by awakening. Arrival suggests that these objects are not only debris, but signs of a galaxy more alive than we thought. Each one may be only geology, but together they may represent the edges of a network we are just beginning to glimpse. If civilizations exist elsewhere, interstellar debris could be their tools, their camouflage, their way of leaving messages that last across eons. If so, then the visitors are not random at all, but participants in a process far larger than ourselves. They may be couriers of information, or probes of reconnaissance, or fragments of civilizations long gone. In this view, the beginning is not ours. It began long before we were here. What is beginning for us is only the recognition of it. The arrival is not of the objects themselves, but of our awareness that they are part of something continuous. Awakening suggests something different. It is not the visitors that are new, but our ability to notice them. Interstellar debris has been crossing our system for billions of years, unseen, unrecorded, unremarked. Only now do we have the instruments to detect them, the technology to track them, the imagination to speculate about them. In this view, the beginning is not cosmic, but human. The visitors are not arriving for the first time. We are awakening for the first time, opening our eyes to a reality that has always been there. The beginning is the shift in perspective, the recognition that we are not as isolated as we thought, the realization that the galaxy is not distant but immediate, present, flowing through us. Whichever perspective we choose, the implications are profound. If this is arrival, then we are participants in a process larger than ourselves, part of a galactic traffic we do not yet understand. If this is awakening, then we are witnesses to the expansion of our own awareness, the broadening of our horizon, the transition from imagining isolation to recognizing connection. Both possibilities reshape how we think about the cosmos and about ourselves. Both possibilities redefine what it means to live in a galaxy that is neither silent nor static. The beginning of something bigger is also a test. It forces us to ask whether we are ready to respond. Observatories have measured, but they cannot chase. Missions have been proposed, but none have yet intercepted. Our response so far has been passive, watching as visitors come and go. If the beginning is to mean more than awareness, then it must lead to action. Awakening without action is only realization. Arrival without response is only observation. The real beginning comes when we prepare to meet the visitors directly, to sample them, to study them not from afar but up close. That step has not yet been taken. The beginning will not be complete until it is. The uncertainty of meaning lingers. Are these visitors signs of danger, reminders that interstellar impacts are possible, warnings that survival requires preparation? Or are they signs of opportunity, messengers carrying chemistry and information from worlds we cannot reach, gifts of data scattered freely across the galaxy? Or are they signs of contact, probes hidden in plain sight, silent watchers observing us as we awaken to their presence? Each interpretation changes what the beginning means. Danger makes it a call to defense. Opportunity makes it a call to exploration. Contact makes it a call to awareness that we are not alone. The visitors do not tell us which is true. They leave us to decide how to interpret them, how to prepare, how to respond. This ambiguity is part of the weight they carry. Humanity does not face clear answers. We face questions, questions that grow louder with each visitor, questions that do not fade with silence, questions that will not go away. Are we alone? Are we safe? Are we ready? The beginning of something bigger is not defined by answers, but by the act of asking these questions seriously, repeatedly, with the awareness that they matter. We are not the same species we were before Oumuamua. We are not the same after Borisov. We are not the same after Atlas. Each visitor has changed us, shifted our perspective, forced us to look outward and inward at the same time. That change is the awakening. That change is the beginning. Arrival or awakening, the direction is forward. More visitors will come. Some will be ordinary, some will be strange, some may be extraordinary. Each one will carry data. Each one will provoke speculation. Each one will hold up a mirror. Together they will build a sequence that cannot be dismissed, a pattern that demands attention. The beginning is already underway, and it cannot be stopped. Whether we interpret it as the arrival of messages or the awakening of awareness, it will reshape how we see ourselves and our place in the galaxy. The first three were enough to show us that rarity was illusion, that silence was not emptiness, that chance was not accident. The fourth will reinforce the lesson, and the fifth and the sixth. At some point, the accumulation itself will become undeniable. Humanity will no longer ask whether interstellar visitors matter. We will ask only what they mean and what we should do about them. That is the real beginning, the shift from seeing them as curiosities to seeing them as central to our understanding of the galaxy. If this is arrival, then something larger is unfolding. Something we have only begun to glimpse. If this is awakening, then we are the ones changing, our awareness expanding, our questions deepening. Either way, the story is just beginning. The visitors are not the end of a mystery. They are the start of a new one. They do not close a chapter, they open one. The beginning of something bigger is not about them alone, but about us, about how we respond, about how we prepare, about how we choose to interpret what we see. And so the question remains, unresolved but pressing. Is this the beginning of arrival or the beginning of awakening? The answer may be both. The visitors arrive and we awaken. They come and we change. They pass silently through our system, and in their silence we hear not emptiness, but the echo of questions that will define us. The beginning is here. What follows is up to us.